change the colors, but you can only pick between like 6 terrible like RGB colors. So I tried.
Check, check. All right. We set up the Chatterino setup on this computer. So we have chat on screen. That'd be nice. I think I have all the fonts installed and everything. I think I can create exactly what I had on the other setup. Do that real quick. It'll only take a minute. You get chat on screen. My fly is down. Jesus. Back up. Man, I gotta wash out that reservoir. It's disgusting. There's metal chips all over this area too. And I gotta move the axis off. We'll work on it again on Thursday. I want to take Tuesdays to work on some of my own stuff. VSTs and DSPs in the world right now. What are we, a joke to you? I know. All right, so now I got Chatterino. I got Bother. Oh, and now I can't move the window. Ha! It's doing that thing where I can't move the window even though I just moved it. Can I please move the window from this spot? All right, well. Add a split channel. No bother. I still can't, it still doesn't let me move the Chatterino window. It's so weird. What? Oh, now I can move it, but it got rid of the split that I just added. What the fuck? Oh, because it opened a new one. Oh my god, dear god. Oh, you know what? It won't let me move it because it's my settings are open. That's why. I didn't realize I had settings windows open and buried. I say open and buried, but they're not open right now. What the fuck? It doesn't let me move the window. What the fuck, Chatterino? What is going on here? There's Chatterino. I have a calculator open for some reason. And Prusa. There you guys are. Metronomic, OBS, Discord. Huh. It doesn't let me move I'm gonna close Chatterino and open it again. Oh, there's live. There we go. Now I can actually move the window. It like locks itself in place sometimes. Okay, so we've got Chatterino and everything. I need to actually change the font. So what I'm gonna do is font size is 12 point, and then we're gonna go to choose, and of course we're gonna go to Avener, which is somewhere on here. It's on this computer. It's all over this computer. But we're gonna go Avener heavy. Yeah, heavy, because we need larger blocks. What is going on in chat? Okay, so regular blah blah blah, layout, etc., etc., etc. Zoom default, horizontal, start with windows, no, always on top, show with channels, live in tabs. I think that's okay. All right, so that's it. Minimal setup. Now everybody is in Avener, which does kind of almost look like Comic Sans. But this window, I'm now going to make a reasonable size to go on stream. Message history service unavailable. Okay, that's weird. So we can move that off screen. And now I can go to OBS. Things are gonna get a little weird here as I work with OBS. What the fuck is my OBS? Where's my OBS window? There it is. It's, what the fuck? My OBS is like missing. Where's OBS? Why is my computer having such a rough time of it right now? There it is. Jeez, it like wouldn't come up. All right, infinite view. Baldisos, hey, thank you for subbing. Okay, so now we're gonna add a window capture. Oh wait, first of all, there's one more setting we need to do in Chatterino. Whoop. Yeah, thank you for the 2 months. All right, do this. Then we go to the background. We go to black. Look okay. So now that's a color that we can key off of. Window capture for chat overlay. What? What am I supposed to do? Back over here. Well, it's actually application, isn't it? Maybe to do an image capture? Or a text box? All right, where the fuck is, there you guys are. All right, let's put you over to a reasonable spot. And then we need to make another one. I need to make another window capture. So I'm going to do plus, and I'm going to do another window capture. That's going to be Chad Shadow. All right, that's good. Take it over here. Now we need to apply filters to these. There's a browser overlay that comes with transparency support. I don't need anything installed locally. I don't know. This is just how I figured it out. I did some cursory Googling and I didn't find anything. But this way I can, like, I have a decent amount of control over what exactly is going on. Anyway, Chad Shadow, we're going to put below Chad, of course. And then we are going to go to the filters on Chad. And then we are going to apply a color key. And the color key is just going to be black. So it's got to be a custom color, select color. Oh, that's wrong. That's the wrong direction. Actually, this doesn't matter. This is what matters. Look okay. All right, there you guys are. Now I'm going to soften it up a little bit. You guys will stay at like 80% opacity. And then I'm going to take the similarity to allow for shaded stuff, I think. The smoothness, I would like to go up a little bit more. I think that's all right. But that's going to look like ass, right? It looks like ass right now, which is fine. So we're going to close that. And now, in order to do this properly, we're going to take Chat's Shadow. And we're going to go to the filter on that. I'm going to add another color key to this. Take it to a custom color. Yoink. And then I'm going to get rid of the brightness and get rid of the gamma. And then I'm going to tweak the contrast a little bit. I think it just doesn't need any contrast. And then I'm going to make it a little bit more... Well, actually, we want a strong shadow, otherwise you're not going to be able to read it. And then we take the smoothness way... I guess down? Up is probably better, but... Take the similarity way down, because I want it to be... I want it to kind of, like... have a bit more of a fuzziness to it. I could probably add, like, a... I wonder if there's, like a... Virtual cam, sharpen, scaling on aspect, render delay, luma key, image mask, blend. Maybe mask and blend would help, but... And the problem is, I can't see anything right now because of the scene. So what I'm going to do is actually, let's see if we could, like, well, I could just blank out. I could just blank out, There we go. Blank that out. Actually, that's not going to work. I'm not going to be able to see what I'm doing. All right, well, anyway, the point is that I now need to place one on top of the other. So that it doesn't look terrible. And then hit Alt. Oh, I moved that a little too much. Ooh, this is a hard mix. And you guys need to be a little larger. Actually, I think maybe I just need to make, I probably shouldn't have done that, because now it's going to be a different size. SDF effects, yeah, blah, blah, blah. Listen, chat, just let me do my thing. God damn. All right, I need to actually make that window a lot larger. So let's go into the settings of Chatterino. I mean, I guess I could zoom in on it. That's almost double size. I will have to play with this a bit more off screen, though. I don't even see the shadow anymore. I think it... Oh, it's moving them both as one. That's why. Yeah, they're slightly different sizes, but as long as I can make the chat stand out a little better. I think that's okay. I'm gonna put these into a folder now. So, group. So we'll select both of these and we'll group them. Keeper of Maps, thanks for the 100. Oh dear God, the Nightbot message. Yeah, I need to do the sizing of things, which it's actually fairly difficult to select the individual pieces of this. What's that even snapping to? Weird. I don't even know what that's snapping to. Yeah, you guys are too big, huh? You guys are a little too big. Oh, let's see. Now I need to do the width of the chat window so that Nightbot messages look all right. So it needs to be this wide. Yeah, thank you for the bits. We could probably make you guys a little smaller, huh? Come to think of it. I wonder if, does this crop? No, this, wait, Alt. Oh, that crops. Wait a minute. Oh, no. I'm just gonna undo the transform on both of these. Hold on, wait. Ungroup those, and then let's, transform. Reset. Transform. Reset. All right, so there's your shadow. Whoop. There's you. On top of one another, but with a little bit of an offset. A little bit of a lower right shadow, huh? And then I'm going to group these. Oops. Wait, no, I got weird stuff selected. You and you. I'm gonna group. Call you chat. And then I can do the cropping. So we can get a little bit more of the screen up on here. And the transparency for chat, I don't know if that's gonna be a good idea or not. At least for this scene, at least for the computer scene. And I could bring that into the other scenes and put it in an appropriate place if it needs to. Whew, this is a fairly driven music, isn't it? Yeah, when you guys are over top of text, it doesn't really work, does it? Jesus, that was too intense for like a little tutorial at the beginning of the stream. Anyway, I'm back to work today. How do I get you out of this? There's no, usually it pops the video out for you. I guess I could do that. There, it doesn't even miss a beat when I do that. Oh dear God, is that guy streaming again? Okay, you guys need to be in a place that's a little bit better. Yeah, I mean, I could give you guys like your own window that I have to turn off. That's what a lot of people do. There's just there's a lot of text on the screen right now. Everything's fairly busy, so. There you go. We'll cover over metronomic. The sunglasses that I'm mode are transparent. Oh dear God, this desk is a mess. What's good is that I can do these both at the same time, so the drop shadow isn't going to be moved by my manipulating of this thing. Anyway, how's everybody doing today? Welcome to another stream. I guess I need to get rid of the scroll bar too. Hold on. There we go. Now I'm going to lock this down. Wait, we got to get rid of a little bit of this, and then we can lock it, and then I can view and unview chat as I please, and I can copy and paste that into the other scenes. Like for instance. Copy. And I can go into this view. I can paste your ass into this chat. Welcome. Welcome to the desk, chat. Ugh, you guys are gross. You're getting all over my stuff. I do need a stronger shadow. I think it needs a much stronger shadow if we're going to be able to see text on like the white stuff over there. But I'll fiddle with it later. Or I could do one of those things where I like do like 2 messages and make them big. Ugh, that's hard to see. It's hard to see. Just like 1 message and it'll be old. Oh no, that was the wrong control. I don't know if I can control Z that. I guess I could just adjust it. That's just to get rid of the scroll bar and make you guys smaller. You don't have to be here, Schmide. Jeez. What an ass. I like emotes. I think they're fun. All right, anyway, I gotta get all this shit off the desk because we're gonna do something different today. This needs to stay local. I'm going to an older mix. I don't know what's going on over here. What are you playing? I'm sure the song comes into its own eventually, but I kind of want the sunrise mix today. All right, anyway, clean off the desk. I will only accept crabbiness from the streamer today. No toxicity, chat. The only toxic things we're allowed to work with are the materials that we're putting together. Problem is I gotta organize all this stuff because I don't want to lose sight of any of it while I'm working on this specific thing. Boop, 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 boop. An old memory of my friend's college apartment a minute ago before I was streaming. I like that apartment. Used to watch a lot of YTMND there. A lot of YTMND. He had this tiny little Philadelphia apartment that had brick walls on the 2 ends. It was basically just like it's almost like a hallway. It was ridiculous. He had a loft bed that was over the bathroom. He had a tiny little kitchenette, and then he had this like little corner where he put his computer desk. And then he had like the TV setup, the typical, you know, like little TV with a couple consoles below it. We played Shadow of the Colossus there. It was a cool setup. I like that little place. He also had a miniature lathe. He actually had a miniature lathe. I need to return these lenses to where they go. They get knocked off very easily because they're on the very top of the y-axis. think he's being extra toxic because he's on screen. Whoop, that one goes in the garbage. The old 3D prints that I gotta kind of like sort out just so I can get a little bit of desk space back, you know? Where's that spacer that was on the desk? There it is. Only got so many of these spacers, I kind of want to keep them together. I don't know if we're going to get to the circuit work today. We're definitely going to do the schematic work today, though. So I can put together a plan of what I'm thinking the whole system is going to look like. And yeah, we'll just get to audio stuff. I need to put an EQ inside of my microphone. I'm not going to buy a digital audio workstation when I can throw some op amps into this amp and, you know, make it neat and unique and make it work very effectively for what I do here. And then I can move this over to the mixer, and I'll have my signature quality audio, the likes of which made this man over here go, "Hey, you're getting that kind of quality out of a lav mic?" That was during the gaming streams. Metro was hanging out. It was good to see him. But yeah, he was pretty shocked that I get the quality of mic that I get out of a lav. It just takes work. It takes work and a lot of frequency filtering. Turns out the EQ is a very important facet of my entire audio setup. The compressor is something that the mixer has. So I can use that mixer's compressor. The problem is the EQ stuff on the Rodecaster Pro is, unfortunately, they decided to do something called aphotex sound, which is more like a, I don't know, it's a different kind of manipulation of the audio, and it's not an EQ. Now, if they put a digital EQ into the mixer, I would be a happy person, but unfortunately, they didn't. They might be able to. They might be able to upload stuff. I need to get my lav mics sorted. Yeah, it takes, I mean, for me, I'm running M Audio, which makes free VSTs that I haven't updated, and I probably should, but it took quite a bit of filtering in order to get my audio right. And we'll talk about that more when I start, when I can get chat off screen and it looks a little bit less chaotic with all the text everywhere. This is not Metro's chat, by the way. This is my chat. It's mine. Look at them. Look at them go. They're all over the place today. Oh my God. Oh my God. Where are you guys going? Wait, come back. Chat. Hey. Oh, I can't get them fully off screen. I can't get the mouse all the way over there. And really, I should do like a browser capture, but this is such a generic scene, this one. I use it for a lot more than just the intro. Now, I am thinking of buying the, what is it called? Blah, blah, blah sound. The epidemic sound, which is hilarious because we have an epidemic going on. But anyway, epidemic sound, I like calling it epidermal sound, but epidemic sound could allow me to put together mixes of my own design and maybe use those. Yeah, I just put away the bin where I put that away. Great. Perfect. Can't find anything today. I'm just trying not to like misplace stuff, because when you clean up, that was a drop. When you clean up stuff like this, I had everything out and in front of me that I would need to perform whatever job that I'm trying to do. And so cleaning it up means that everything has to go somewhere. The Nightbot messages are, yeah, those look right. Okay, cool. The 2021 sound. Yes, I'm using ancient 2014 audio tutorials to put together the circuit to do this filtering, because I bought a $600 mixer and they can't even provide me with proper digital audio tools, which is wild. Absolutely wild this day. I'm gonna sweep. I cannot, this floor is shocking. There's like gum wrappers and like, it's like a super fun site. The hell have I been walking on? I've been pretty lazy past 5 days. I've had a lot of stuff going on, a lot of IRL stuff, a lot of people coming out of the woodwork, some drama, all kinds of stupid shit that I just kind of want to leave behind today. I just felt kind of overwhelmed by the work that I had to do and what I had to accomplish. And then in addition to that, I had a hard drive cooler that decided that it didn't want to show up on time. So that gets here today because I had to reorder the fucking thing. Because the first shop, I guess, was like, oh, we got an order for this thing. And they're like, and then they just didn't send it. They just immediately refunded me.
Thank you for the 10 gifted subs. I appreciate it.
Oh my God.
And good morning.
Gifted subs.
By the way.
Hold on.
Thanks for listening.
Wowee. You guys should absolutely follow Metronomic, by the way. But yeah, I just felt kind of the weight of the world. So I decided to game for a little while. I put way too much time into games, which is probably a symptom of what I was experiencing. And then I get streamers giving me gruff for watching their streams. It's like, I'm sorry I'm here watching your stream. I'm sorry. It's ridiculous. You know? I don't know. People suck and the music muted. Speaking of people sucking, stupid DMCA muting. All right. Okay. That's a little better. I can at least look at that floor and not be appalled. I guess I'll undo HDMI over here. Just fully convert to game streaming. It might ruin gaming for me if I do that. All right, over here. There's still shit on the floor. I didn't do a great job of sweeping. Premier's gifted a sub to Flatulent Gonad. Hey, thank you. All right. Yeah, delivery instructions. Throw directly into the void. They did it. By God. They're so good at their job. Yeah, it's like, why list it if you're not going to sell it to me? That should be illegal. I guess I'll keep that on the desk. These I don't need. Bracket goes with the brackets. Cleaning up always makes me feel a little bit better. Oh, that bin is in the wrong bin slot. Or is it? Wait a minute. Oh no, this one goes here. Standoff's bin. I got a project for Julian. He is absolutely champing at the bit to get me to build him a synth of some type. And he wants to be on the show. He's been texting me so that I don't forget, because I will forget, because I'm a very forgetful, I suck. I'm a very forgetful person. But he's been champing at the bit to get on the show so that we can work on a Raspberry Pi synthesizer project that he found. And so I'm gonna be taking a look at that. I'm gonna be doing project assessment on Wednesday. What's up, C? I hear crows outside. This thing with chat is supposed to lower the toxicity. Some people are immune to it, apparently. All right, clean desk, clean mind. Whew, it's a little warm in here. I'm gonna turn the fan up. It has cooled off on the East Coast, at the very least. This last one's not coming up. Give me my parts, 3D printer. right. This this can go here. I do need to clean up the whole shop at this point. And there are like screws and shit on the ground. And they're not going like, okay, all right. I'm triggered again, I'm sweeping again. My own nasty ass floors getting to me. Getting to me, getting to me, getting to me. Too much neglect. Too much neglect around here. Too much neglect. Not enough effort. Streamer's lazy. What a lazy streamer. He's such an asshole. I'm gonna say toxic things on his stream. All right. We don't need to hand drill today. Set the battery up over here on the wall. Drill away. Big battery up. Good to go. All right. Back over here. Throw the countersink in there. Back to the desk. All right. Oh, other parts. And then, yeah, I need to quit Fusion and the other. There's an update for Fusion, so we need to do that before we start. Good over there. Good over there. Closing stuff down. Good to go, good to go, good to go. I think so. Oh yeah, drink. Drink, drink, drink. I want to get dehydrated. You die instantly if you're dehydrated on stream. Man, Metro's not even here. What's going on? You guys will take his place. There you go. Move you back down. I want to keep those redemptions up on screen so that you guys can be properly shamed. The area behind my keyboard on this desk has gotten completely out of control and I need to take it back. I'm not going to do that today, but... How dare you, Dion? I knew the likes of you would do something like this. It hit the recycling bin, but then it bounced out. Oh yeah, Fusion. Foos! There he is. Huh, that one didn't cut out so well. Yeah, I gotta fiddle with the shadow and make it a little bit more natural. Looks better on the game computer. Possibly making the window slightly larger so that it's text inside of the inside of a black outline. It's gonna be a little jumpy like this for a minute because it started a massive download. It's gonna get up to 98 and then it's gonna spend 4 minutes at 98. I think it position locks them when... Yeah, like I can only move you guys as a group. So I have to ungroup in order to move you guys around, which is annoying. I wonder if Fusion really understands how much their software hobbles everything else when it updates. They might as well just bring you to like a downloading update page instead of letting you try to struggle to use their software while it basically throttles your internet. There it is, 98% for the next 4 minutes. You're not at 98%. You need to change that. You need to linearize that a little bit more. Absolutely ridiculous. How am I supposed to budget my time around this when 98% invariably spends 5 minutes updating? Maybe you should change the algorithm a little bit, how you're determining what amount of progress is being done. Maybe you should show it as stages instead of a little dial that charges up. Jeez, and then you have to restart. Yeah, I really don't want to put you guys in an opaque window, you know? I think just a slightly better drop shadow would do it. Here, let me bust you guys out of this right now. You're busted out of the group. I'm gonna expand the shadow a little bit. Yeah, it might look a little bit bad, huh? Yeah, because that expands it in all the wrong ways, huh? It needs to be like a larger font or something. Yeah, the problem is it doesn't do a proper outline. Ooh, wait, I just clicked something. Hold on. All right, ease up. Everybody's a critic. Why isn't it? God damn it. Moving the display capture instead of what I actually am trying to click on. I click on this, I click on this, and then it's selecting everything but. Look at this. Ah! All right, we'll leave it like that for now. Actually, that's not very good towards the bottom, huh? It's good right there. I think the sizes are still different. The OBS makes it very difficult to select certain windows. Like, I'd like to move this scene, please. That's why I need to, like, unview display capture at the bottom, but then I can't see the shadow if I do that. There's the shadow. There's the rest of you. And it also doesn't snap to its own window. So we move you guys up 2, over 2. That looks all right. And then I group them again. I have to regroup them. Selected items, and then I can take off the borders. And move them both together. I think on larger devices this will look okay, but all right, you guys get to go away now. Yeah, it just, like I said, I gotta fiddle with it, you know? You gotta fiddle with it in order to get things to look right. White background. Over here. Actually, the better white background is just gonna be Fusion. Yeah, it's still a little bit much, isn't it? I think the fuzziness, I could play with the fuzziness settings to try to fix that a little bit. But oh well. Anyway, you guys go back away. I'm gonna put you guys. I don't know if I should keep you guys there or if I should put you away for chat for stream. I think I'm gonna put you guys there. We're gonna try having you around today. We'll have you guys around today because we're gonna be doing a lot of internet and stuff like that. So let's carefully fade out Metronomic Live. There's my fade out, my very advanced fade out. I got a couple web pages to open in addition. What are we working on? Well, if you guys didn't know, I use Pantene Pro V. Yeah, that's the shampoo that I use. I use Pantene Pro V. Thanks for watching. Anyway, no, I use a lavalier microphone, a lav mic. It's an electret microphone. There are all these terms behind microphone and audio equipment and stuff like that. We're not working on Burn the Subs, and the reason behind that is that I am burnt out. I'm completely and utterly fucking burnt out. In addition to that, I'm waiting on parts, which is very, very just, it's vividly frustrating waiting on parts in the way that I'm doing this. Yeah, so what am I doing? Well, today we're going to work on audio equipment, and I need my audio equipment to work with the extremely expensive mixer that I bought that is currently a very advanced paperweight. This is the Rodecaster Pro. It's for podcasting. It has a record button, which is absolutely not Twitch streaming. However, it's got this big Fisher-Price interface, which I would actually rather it be a little bit smaller than this. But it's got this big Fisher-Price interface, and it's got a lot of digital stuff that it can do in order to route your audio around and make it sound good. That's what I'm going to be trying to build up to at some point here, is having a better, more robust audio setup that would allow me to, for instance, be a guest on somebody's Zoom and not have horrible crackling audio from a virtual audio cable. This happened to me with the doctor's appointment and Blue Jeans. I tried to set up, I did a family Zoom call, you know, right at the cusp of the pandemic, and I think that worked out okay, but I think maybe everybody was polite, because I tried to join a Blue Jeans doctor's appointment, and there was a horrible, awful audio crackle from, I guess, the virtual audio cable. Maybe it couldn't deal with something on the bandwidth. I don't have any good theories on it, because virtual audio cables are fairly hands-off. You just kind of add a virtual audio cable to your setup, and then you send the device audio, like one program's audio, to the virtual audio cable, and then you take it from another, you know, you have another program take it from the virtual audio cable. They're that hands off, right? So I don't know what the hell happened there, but when I tried to join a Blue Jeans call and do a video preview, I was getting horrible crackling noises, and I can't do anything about it because everything that I do is connected to OBS. It's ball and chain, like locked into OBS. I can't do anything about that. My mic has to go into OBS. So if I'm gonna do games with friends, or if I'm gonna join somebody else's like stream as a caller, I need to have my mic filtered properly. And I thought this thing would be great for that, because then I could have, you know, sound effects, do 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 do, boop beep bop bop, you know, sound effects going on, and then I could have other things like my computer coming in there, and then I would have the ability to have my microphone adjustable on my own end, and then actually have like a guest microphone and or a guest's, you know, music instrument setup that can plug in, right? So I can't do that currently because this thing does not filter the lav mic properly. It doesn't have as good of an EQ. It has the compressor. I could make the compressor work for me to a degree. I don't know if I could get exactly what I do out of my compressor out of this thing, but I could get close enough on that. And then I can't get the 6-band EQ. It's got Aphex on board, which means that it doesn't do EQ filtering. It does whatever the hell Aphex is. So I started looking up stuff, and of course I found myself at the webpage that I always go to, which is Elliott Sounds Projects, and we'll look that up in a minute. I still have 5 windows open on the other computer, and I was debating whether or not I wanted to paste them into my admin channel so I could pull them up instantly. But I'll just find them again. Elliott Sound Projects. Elliott does a really good write-up It's not comprehensive as write-ups, and it seems like you need to go through pages and pages of other pages and other articles in order to get up to speed with what he's talking about. He works a lot in the same way I do, where I forget to reintroduce people to the basics before getting into something that I've been thinking about for a month. So, Elliott Sound Projects has a lot of really amazing stuff in it. A lot of op-amp circuits. This guy operates in op-amps and transfer functions. That's one way to do it. I have debated on doing it another way as well, with an FPGA. How long were you lost down that particular rabbit hole? About 2 days. 2 days of homework. I got all the notes to prove it. I got the notes, and then I got, I think another, there's another page of notes. Another page of notes, and then there's, I think, a third page of notes. Nope, that's the BTS list. Filling me with dread. Yeah, I've got 2 pages of notes worth of me tootling around with audio stuff, right? So anyway, I got to work at Elliott Sound Project. Took a look at Project 93, which is what I use in order to amplify the lav mic off of Phantom Power from my Focusrite 2i2. The Focusrite 2i2 is just like an audio interface that you plug into your computer. Works really well. Plugged it into the computer. It's basically my sound card. I have Phantom Power coming out of that. It goes to a mini XLR connector on a little box called, or at least that I like to call, the Elite Core. This thing is another product. It's just a different product. It's got a headphone cable on one end and an XLR, a full-sized XLR on the other. I capped it off with 2 mini XLR connectors because the lav mic uses a 5-pin mini XLR, and then I've got 3-pin XLR, and my cable, the cable that I use, is a 3-pin XLR to 3-pin mini XLR. So that is plugged into a little box that I magnet mounted to the side of the desk, and then the cables run behind the desk into the rack where it gets to the Focusrite. So that's the physical part of my audio setup. But inside this thing is a little circuit board for something called Project 93, and it's an Elliott Sound project. I had to look that up because I figure if I can put the equalizer in between, basically smack dab in the middle of Project 93, I could add it to the audio system with Phantom Power and not have to deal with like adding a box near the mixer or messing around with something that would take out Phantom Power and then put Phantom Power back in. I don't have to buy an EQ from somebody. It's possible that I could purchase an EQ that would do the job that I needed to do, but it'd be like $300 in one channel. Whereas, you know, and then I'd have these knobs on the front that if anybody touched, I would have to murder them, and then I'd have to hide a body. And I don't want to hide a body. So that's kind of what I'm dealing with here. Like I think it would be more convenient to add the EQ to the microphone box that is always associated with that microphone. So you tune it for that mic, and then you leave it there. You don't touch it. And hopefully things don't vary with temperature. That's the idea. That's kind of what I want to tackle. But I've got something of a size issue here. Story of my life, right? I've got something of a size issue here. This camera does not look calibrated. Everything's washed out. What's going on there? Hold on. Setup. Arm procedure. I feel like when it sets its white balance, it does it on the fly. It's so weird. Yeah, see there. Now we're back to normal looking stuff. So anyway, I don't know if I'd call myself an audiophile. I'm more of an audio realist. I'm more of an audio realist here. Oh, wow, that's actually, what's that band doing at the bottom of this? Hold on. Nope, that was the wrong button. Make you guys a little smaller anyway. I'm putting you in the corner. I'm gonna bring that up a little bit. There we go. No, it wasn't just that. No, it's that I didn't have all the lights on when I did this, you know. I'm not an audiophile. Okay, so the Elite Core is this little belt box that has one connector on one end and another connector on another. Follow me for all the great tips like that. Anyway, what this thing is, it's basically for like, I don't know, like Stooge Crew or something like that, right? It's for like, you know, people doing theater stuff, I guess. Somebody's got a use for this because they sell it. But it's this neat little aluminum extrusion box that I hang on my belt. I built this little circuit off of the Elliott Sounds page, and I barely got this thing to fit in there. And you can see, I mean, I'm using the big JST connectors and the big surface mount capacitors, and then it's got a dual op amp in there. The dual op amp does two things. One, it receives the Electret microphone, and then it also amplifies it to send it back on the XLR. That's pretty much it. I mean, it's almost a one-layer PCB. Almost. It's almost a one-layer PCB. There's room for more circuitry here. Now, I don't know if I can do it on the bottom of this. I don't think that's totally possible. And I got the black PCB because chat told me to. I wanted to see what Seed Studios' black PCB solder mask would be like, and you can't freaking see the traces at all on this thing. You have to bounce light off of it to see what's going on. Now, this is going to become part of our setup for the breadboard when I decide to test out some of these Elliott Sounds things. That may be sooner than you think, but I would like to get things together, and I'll show you what I was looking at for all that. The alternative is that I get the audio from this thing. I put it in an I2S converter, which is inner chip sound, like I2C, I2S. So I2S has more to do with turning audio into a digital signal. And then it basically it does it at a very high quality, but I2S would turn it into a very high quality serial? Yeah, I think it's serial. Yeah, it's not parallel. I think it's serial stream of audio that you can put into an FPGA. You can then run it through some pretty advanced filters that'll run pretty much instantly. And then you can, there's still like an edge over there. What is happening with that? Hold on. Chat, hit Alt, and just bring it in a little bit there. There we go. No more little dots on the screen. It looked like stuff on my monitor. But yeah, you can take that I2S signal, put it into an FPGA, output it from the FPGA as an I2S signal, and then turn it back into analog. So that's the alternative idea of what I could do with the audio processing in such a small area. But the circuits that we're going to look at today are analog. They're analog, and I'm going to put them together, hopefully, so that we can get some good sound. Now, this board I designed in Eagle, not Fusion Eagle. So the files for this board are squirreled away somewhere in my Eagle library, and I could try to import them to Fusion Eagle. What's the point, though? We can build this in Fusion Eagle again just as quickly. One of the things that I wanted to, sorry, I forgot. One of the things I wanted to say earlier is that this board is the 1.6 millimeter thick board. It doesn't fit into the aluminum extrusion slots. I have to kind of like file it and do some crazy stuff to get it to fit into the slots on the side of the board. This one actually seems to fit, though. I think maybe it was too wide or something like that. But over the break, over like Saturday and Sunday, what I did is I took this extrusion. I took this extrusion and I very carefully reverse engineered it. Very carefully reverse engineered it so that I could get it into Fusion Eagle. Get into Fusion, basically, and then I can use Fusion Eagle to design, to my heart's content, the circuit boards in there. The one that I'm using more recently is iFixit. Yeah, it's pretty much just iFixit. They're a pretty reputable company. Oh God, I've got to disable ats on. I gotta disable ats. They seem to be kind of cancerous. One sec. All right. Let's not be toxic, all right? Let's see. How do I disable that? Go into settings, I guess. Settings. Highlights. Boop, 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 boop. No, I don't think that did it. Hold on, settings. Don't do anything. You're only supposed to display chat. I don't know if that did it. I don't know if that did it. Man, Chatterino is extensive, isn't it? There's a lot of stuff here. Oh, yeah, I guess it did. It did it retroactively. Okay. All right. Cool. All right, we're back in business here. Alrighty. Anyway, this is the iFixit set. I like it. I think it does everything I need it to do. I have the big iFixit set, but I don't use all of it. I don't use the big iFixit set. It's got a lot of screwdrivers and stuff that I just don't need. This has pretty much everything that I've needed thus far. I haven't been without the appropriate screwdriver bit in quite some time. So yeah. All right, anyway. The Elite Core. We got the problem. Nobody's going to tell you what went into their aluminum extrusion. I tried looking up aluminum extrusions all over the place to try to get a 3D model. I wasn't able to find it. So what I had to do is I had to go all the way back to my roots and reverse engineer. Well, mechanical reverse engineering is not my roots. I need to make a stream project folder here. Let's see. Beep, 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 bonk. This thing right here. This is the model that I made in Fusion. And boy, howdy, did it take quite a bit. Let's look at this sketch. This friggin' sketch here. Look at this thing. This is a nightmare. It doesn't help that when you do center squares, it'll basically highlight. It'll make a dotted line through the center of the center square. And this thing is a lot of different squares. What I did is I did all the dimensions I possibly could. And then I made them into dotted lines. I need a triangle bit for my kid's Brio. Let me see if I have that. Do I have a triangle bit? I know triangle bits. I used to have a full comprehensive security bit. Yeah, there it is. It's right there. Yeah. I don't know, man. That's hurting my brain. It's hard to see. It probably should have been multiple layers, but then you don't get the highlighting. Maybe I could have done all the dotted lines on a different drawing. I tried to move all the dimensions out of the actual thing so that, you know, it wasn't a total nightmare. But the whole point of it is that there are multiple squares inside of here, and there's like cut off circles, and I had to go back. What I did is I plotted everything out, and then I highlighted the whole thing, and I turned it into a construction line, and then I double clicked on the outside edge, and I turned that into a solid line. And then I went through and I traced each set of squares, trying to keep them separate from one another. I did this while watching a video about Batman, which is weird because I'm like thinking about that video now. Yeah, even like the little lock piece I modeled, it didn't have to be completely exact, but certain facets of it did. Like for instance, these little cut-ins on the extrusion had to be precise because those are what's going to drive the mounting of the circuit boards in this project. I'm thinking boards because I don't think we're going to get away with just one board on this. The capacitor size is going to be a very big concern of mine, though. But yeah, getting that extrusion into Fusion took a little bit of work. Now, I know everybody thinks they have a different way of doing it. Oh, bother, why didn't you do it the way that I want you to do it? Why don't you use my IDE? But anyway, yeah, so basically, this is a nightmare. Uh-oh. Click and drag something I didn't want to click and drag. I should bring these out too. These are all the same dimension. Those are for the cut-ins for the circuit board, so those will be important for me to look up later. Anyway, yeah, that was an absolute freaking wreck. What a nightmare. But I got it together. And I was able to extrude it into a solid. I, of course, colored it gray instead of black because I wanted to actually be able to see what's going on as we go through the design. The actual thing is black, and it is textured like that. This is a powder coat, like a rough powder coat, according to Fusion. Instead, the actual thing is painted matte black. So yeah, pretty good. So we got our base for working on this thing. And that is accurate to what is actually in the Elite Core. Here, it blew up. So aside from the shoddy paint job on this area, that is basically what we have. We have 3 tiers to hang our circuit board from, and it's basically a reversible piece and all the stuff around it. One of the things that I did run into was this chamfer I did not want to have driven by the actual like edits on a solid, because this is like an extrusion profile. All the facets need to be in there so that I can just extrude it out. And then I looked up why every single time you do a chamfer on a drawing, it pulls up an error in Fusion, because you're getting rid of, I guess, some of the associations or the dot in the corner. Every single time it pulls an error, which is not good program design in my mind. I looked it up, and they're like, you shouldn't be doing the chamfers in the drawing. You should do it on the solids. It's like, well, yeah, maybe in typical CAD, but I'm actually looking to design an extrusion profile instead of trying to build the solid from nothing. I don't know. I just thought it was kind of dumb that they would say you're doing it wrong. Anyway, that I've pretty much replicated the extrusion profile. I wanted to have these things together for stream so that I could show exactly what I had built. Man, there's a lot of red in this shit. What is this camera doing? It's like it's not this red in real life. Actually, it is kind of close to that red in real life. It's like glowing. These are new. These aren't on the original one, just because I didn't want to have to design an aluminum piece in order to do that. And then the only plate that this thing has is on that end, because the other end is a full XLR panel mount. So I instead of trying to like get metal and cut metal, I figured I could just 3D print it. That also gets me a couple of extra millimeters in here, which means the connectors are going to be spaced out a little bit more. That'll probably get me 1 additional millimeter. Even though I'm adding 4, I'll probably get 1 millimeter more out of the circuit board, which is all that means everything, right? That's very important in this project. There's not a lot of room in there. Also, this is the core of the Elite core. This is literally how it's built. It's like really shoddily soldered together. I don't know what the non-elites are using, but man, I would struggle to make a lower quality thing. Anyway, I love the enclosure for this thing. That's why I use it. It's just got the nice little belt loop. All right, so anyway, in my pursuit of modeling the interior of this space so that we can fully maximize its usage, I had to do a couple more things. So I made the end bits. That was all well and good. Then I had to go to Switchcraft's website, where I found 2 through-hole versions of their mini XLR connectors. The only reason I found Switchcraft's website is because DigiKey listed for those 2 at the bottom that there was a 3D model. It tried to get me to log into some shady-ass website. So I was like, well, who makes them? Switchcraft? Look up Switchcraft's website. Get on there. Turns out you have to make an account, and that website is like 1 step away from being entirely in Comic Sans and built out of HTML. And I'm like, fuck no, I'm not giving you my email. I did Bug Me Not, and I actually found a username and a login that was 80% effective, and it worked for me. So I was able to log into Switchcraft's website using illegal means, and then download their 3D models of their connectors, the ones that I use. These came with no coloration to them. They're gorgeous. Like, it's a gorgeous 3D model. This is an absolutely gorgeous 3D model. Oh, I missed those surfaces down there. Look at this thing. It's beautiful, right? I had to add the nickel and the gold and the black. And so what I did is I ended up coloring the entire thing black and regretting it. Because I think I made everything nickel? No, I made everything black, and then I came through and I added the nickel and then I added the gold. But man, getting this stuff, getting each of these solids the appropriate material was absolute fucking torture. I probably should have colored it all gold, because man, that was a lot of clicking. Actually, the reason that I did black first was so that I didn't have to go into these edges, like the edge of the 2 that's made up of several different triangles. There's so many polygons in this thing. This is like gorgeously detailed. I'm shocked, given the quality of Switchcraft's website, that they have such a good 3D model. It's a beautiful model. So we're gonna make the most of that. I got the 3-pin and the 5-pin, and I changed all the coloration on it because I'm a sucker for good visuals. So anyway, from there, I was actually able to put them against the Elite Core. The plate I actually made as a separate document instead of making it as a, you know, a body in the main thing. I probably could have made this as a body in the main drawing, and I used the hole tool in order to do the chamfers, which meant that I had to do them from the sketch, and the sketch was on the base, so they ended up being underneath, which is a little weird for the 3D model, but it's somewhat acceptable. All the dimensions, of course, came from the 3D models, and these dimensions came from my measurements. And since this is a typical panel mount, like slot or whatever, it's a standard thing, right? It's like a Neutrik panel mount XLR. You can find those dimensional drawings, and I found one on DigiKey and just use those dimensions for this. So I made sure that all of my stuff was correct by checking it against external devices. So once I had that, I had the whole body of the thing to go together, except for the belt clip, which I don't need if we're gonna maximize the amount of space. But maybe I do, because look at this. Those rivets pretty significantly encroach into the main body of this thing. So if I am min-maxing this space, I'm gonna have to be very careful about those 2 little rivets that hold the belt clip in. So that was the next adventure. I didn't do the orange peeling on the paint. Probably could have done that. But the next part of the adventure was figuring out exactly what dimensions this clip is. There's a couple different things driving it, and I don't think this is 100% accurate. I had a good caliper session with it in order to produce the first sketch, which is a bunch of circles that are supposedly defining all of these different surfaces. And I had to use circles and not chamfers because the radius changes on the inside and the outside of the bend. Now I know Fusion does sheet metal stuff, and I haven't had an opportunity to play with it, but there's a whole category of sheet metal things that I probably could have checked out in order to make these shapes, but I didn't end up doing it. I measured it as about 1 millimeter. I got like 6 millimeters and 8 millimeters on those. Copied that there to a degree. Well, actually, what I did is I came out and made the chamfer on my own, but I based it on the thickness of the material. Very strange process. Oh, wow, can't see that now. Thank you for the follow. I'm going to put that over my face, actually. Here, Streamlabs, you're coming with me. Oh, no, you're not. Chat, get out of this. You're not involved. Hold on, let's, oh, wait, it's just called group. Rename the group, hold on. Oh, whatever, I'll keep it as group for now. Let's take you guys, go away. Hey, Pilot, how you doing? And then we'll take Streamlabs, move it up here, and then I'm gonna lock it in place. Hopefully that's a good place. We'll see. Alerts are now gonna come over my face here, appear over my face. How you doing? I'm doing all right. I'm a little burnt-outy. That's why we're working on audio stuff, because I'm gonna have more fun working on audio stuff than I am burn the subs at the moment. But that heatsink's coming in, so I'm gonna have to do more Fusion. More Fusion 360, which I'm getting better and better at. What I didn't expect was that the rivet would allow me to chamfer it so far in. Rivets are kind of weird because now there's a line on, I fucking swear, every fucking time I try to do stuff with this and it just gets weirder. Like, I think it feels like it changes the cropping every time. Anyway, all right, nice and clean. All right, anyway, rivets. There's no tool to make a rivet in Fusion. I didn't find one, at least. Maybe there's like a user language program that helps you do that. But yeah, no tool to help me make rivets. And that basically what that is a 1.5 millimeter vertical extrusion to get it to the right height. And then I put a fillet on the edge. For some reason, and I don't know what settings I did for the fillet, it allowed me to actually make that dome pretty large. Oh, maybe because it's tangent? It allowed me to do it? I don't know. Either way, it created actually a really good representation of the rivets on this thing, and I'm shocked. Even though these are fully round, it made a decent job of it anyway. I mean, there's still a flat spot on the top, and then it errors out if I go a little further than that. Good enough for the 3D model, though, right? But the problem is that's not really what I'm here to model. What I'm here to model is the other side of it. So what I did, I kind of cheated because I could have had the rivets as their own parts, but I decided to attach them to the belt loop. What I did is I offset this not based on the thickness of the container, not based on the thickness of the thing they're going on, but based on my measurements from outside to outside. I don't know if it's a McMaster part though, because this is built in God knows where. I don't know where the Elite core is coming from. It's not built out of McMaster parts. So it comes with the belt loop, but yeah, the rivets are like weird. Actually, they're not like a typical rivet either. Let's see, how's this camera doing? Look at that. They've got like a weird, like, I don't know. It looks like a pretty nice rivet gun that they used on these things, but yeah, I don't know where I would find these, and if you found them on McMaster, I would wager that they will give you the rivet before it's been pressed. Yeah, it's a weird one, right? They have some kind of a tool that like centers itself and then beasts out the sides. And then they have this weird washer on the bottom of it, because the reason for that washer is that it's actually on the circle radius of the enclosure. The enclosure has a circular radius in it, and I think that's to accommodate the very large XLR circular radius. Maybe. I don't know where Elite Core bought this shape from. I don't know where companies buy this kind of shit from. It'd be interesting to know like where they get, like, did they look it up in a catalog of extrusions that were available? Or did somebody have a bin full of them and was like, hey, or did they find it at like a specialty website? These, I've seen a lot of these in like Conduit and stuff. A lot of you know, I probably shouldn't tell you guys where to source your device enclosures based on my experience reverse engineering IEDs. That might not be generally a very good idea, huh? But I've seen a lot of enclosures, and also ones that you just buy for like regular engineering projects and stuff, that have sort of a layered, it's kind of a thing from like the days of old, like the 70s and 60s and 50s, 80s and 90s too, of building like scientific devices where you have your own design sitting in some kind of a metal enclosure, and so the inside of that enclosure has a lot of different like features in order for you to hang your circuit boards around. So this could take 3 circuit boards potentially with some very small devices on them, or 1 or 2. But yeah, I wanted to make sure to accommodate this properly. But yeah, this enclosure seems to want that. It has a circular radius in the thing right there. Your comments are up on screen. I'm not the one who said it. The joint engineering IE and whatever. Fuck it. All right. Anyway, where was I going? Oh yeah. This shape, the shape of the Elite Core, has a giant circle in the middle of it. It's very strange, as well as about 10,000 little boxes. But yeah, I was able to reverse engineer that. Then I went over to this and I measured the height of the washer and then the height of the rivet, and then I did an approximation of what the inside of the rivet looked like. I'm actually pretty happy with the way most of this drawing came out. I didn't change anything. Why? And then I'm gonna have to update all the references. So let me close all this stuff. What I ended up with is the basis for this project. Yeah, I think they rolled us into that towards the end. Update external references. Oh, whoops! I left the sketch visible. Why that's a savable change is beyond me. And now I need to update the reference again. It's so annoying. All right. There it is. That's what things will look like when I assemble it. I wanted to have this assembled like this so that you guys could see it, but that's cute. I got my citizenship from a general. Yeah, man. So there's all this stuff. And of course, I made the body of the thing gray, so it's not exactly going to look like this. I've had a love for the red filament lately. You guys can tell when I'm working with anodized black stuff or just stuff that's painted black, the red looks really good. It pops. The cameras hate it. This one trick the cameras hate. They really hate the red. It's like fluorescent under the cameras. But anyway, that's what I did over the break. I wasn't just playing Satisfactory all fucking day. I will change this whole channel into a Satisfactory stream, but nobody will watch. Anyway, so yeah, all the rivets are represented and everything. I've got all the spacing that I need. I can start playing with the design of circuit boards in order to put all of my electronics into it. But what are we putting into the circuit board? Hell if I know. I fucking didn't do any of my homework. No, I do actually have a very good idea of what we're doing. This is the old one. This is the old one. The new one is going to have many more op amps on it. So I started with the Elliott sound pages, right? Let's go over to the internet. Let's take a look at the internet. Ultron looked at the internet once, and he wanted to destroy all of humankind, which is a totally natural and reasonable and understandable reaction to seeing the entirety of the internet. Tubular and semi-tubular rivets. Interesting. Yeah, the ARG. Hey, Rodrigo. Okay, please don't dox my searches. There's gonna be weird stuff in it. Like left to gym sock and just weird shit like that. All right, so yeah, that's essentially the link that I wanted to go to, but you can just literally Google Elliott Sound Projects. Elliott Sound Projects is a great site. Boop-a-doop-boop-boo. Let's zoom out a little bit here. Project list. Look at this thing. Here are all the projects. They're not all audio projects, by the way. There are just a lot of different things in here, and they're all done in sort of a modern way, but with some old school stuff. So part of Elliott's thing about using lav mics was for one-to-one audio recordings of nature, stuff like that. Like it's not necessarily like it's not all guitar amps and stuff like that. So recording the sounds of nature in nature with a lavalier an Electret microphone to get the most one-to-one sound that you can possibly get. Project 93 was part of that. There are some considerations that I have with it. A lot of the stuff that he talks about is removing the actual bona fide Electret microphone from like the old school AT&T telephone headsets, because apparently they were using microphones that they had no right to use that high quality of a microphone in a telephone headset, because telephony knocks the quality down significantly so that they can put multiple phone calls on the same lines. Now, goddamn, am I glad the telephone network is going away. It has a very slow death, but man, the telephone network was just a jerry-rigged mess of cables that all somehow worked. It's a nightmare. And for some reason they decided that everybody would like the lowest quality audio. Most of it is cost savings on their part, but they don't even need to do that anymore now that everything's digital. Anyway, it's ridiculous. But so anyway, Elliott Sound Projects, lots of cool stuff to look at, lots of write-ups in here, lots of how-tos. Our project is Project 93, and he introduces basically all the stuff that I just explained to you, in addition to a bunch of extra little bits and details and cool stuff that he's kind of cooked up with Electret microphones. You do the Bob Barker microphone if you want and keep your pinky off of it. Anywho, so his preamps and stuff like that, he does through-hole. A lot of audio people love to do through-hole designs, mainly because it's repairable. My friend of mine who does audio stuff in New York, he basically has had to open up his mixer in order to repair things several times on the job, under pressure and all that. Like, sometimes you have to edit your setup live, and so being that a lot of audio engineers are not that cool with very precision soldering, they're good at audio, you know, they haven't been training with an iron, although I think they should be pumping iron. But anyway, they should be training on the iron, because surface mount is not that hard. If you do big surface mount stuff, it's actually easier to work on, to me at least. Friend in New York show off. Someday I'll have a friend in New York too. I'm in New York and I don't have any friends. Anyway, always do the grape lady impression for some reason. Anyway, yeah, he does through hole stuff because it's easily repairable, right? If you guys didn't know, the other Lone Star is in New York. New York City. I would love to get the Tandy boundary microphone and use that, but while you were partying, I studied the iron. Pressure zone microphones, stuff like that, right? So he's going into all this stuff, and he has like certain ways that he likes doing things. The main thing for me, though, was finding something that would take phantom power and power an electret microphone. And here we are. This is the circuit that I decided to use. Now, Elliot doesn't even like this circuit. He doesn't even like this circuit. Elliot doesn't even like this circuit. He didn't like it. He actually uses, because I don't know, he's a bit of a perfectionist, I think. But he actually has a design that uses transistors. That's this one right here, and he prefers this one to the other one. I, however, have been using this guy right here. So what this circuit does is it takes in phantom power over here. Phantom power exists for like microphones and stuff. You get 48 volts at very low amperage that's being taken on the same line as your audio. With phantom power, I haven't looked up phantom power in a while. I know it's like spooky action at a distance. It's weird stuff that happens on the lines of the microphone in order to give you that power. I forget whether or not it's AC. I think the way phantom power works is it's delivered in such a way so that the differential that exists on the audio lines doesn't see it, and then the differential on the audio lines that provides audio is easily extractable, right? So I haven't read up on it in a little while, but whatever. I could look it up on Wikipedia and then I'd pretty much repeat all that stuff to you. I'm relaying what I remember. But that's what this whole thing is about. That's what this whole start of the circuit is about. With the resistors and the capacitors, I believe, just like helping to filter everything out. The Zener diode, is there? No, there's no Zener diode. Okay, yeah, anyway, you get about 14 volts out of the circuit. So 14 volts that you can use for your various stuff. You get a couple hundred milliamps that you can work with. Now, I had to do a little bit of a milliamp calculation in order to make sure that I was able to put that many op amps on phantom power. Elliot himself would poo-poo that idea. However, I do have enough power on phantom, so I'm going to try to do this. And we'll try to do it with op amps, at least at first. Now, if we have to go digital, we have to go digital. That'll use up a lot less current in its filters. But this is what you're listening to right now. This circuit. 2 op amps working in tandem for the greater good. 2 op amps. The first one is just simply an amplifier. I'm not sure. I think it probably inverts. There's probably an explanation about it that I haven't read in like 3 years. First amplifier is taking in the signal from the electret microphone, which is partially powered by this 10K resistor. That amplified signal is then pooped out directly out through some stuff all the way back to your audio system. Then you have another op amp in here that inverts it and sends it out on the other line. So pin 2 and 3 are going to be inverted signals of one another, and that way, if there is a common mode noise, they'll both go positive or negative at the same time, and that gets filtered out. That's how XLR mic audio and all that professional stuff works. It's very good at its job. So that's essentially what we want to achieve here. We want to be able to get that audio signal out of this, and then we can pump it back onto the line. Now, I'm not sure. I don't know if I'm using both pins. Apparently, later on down in the write-up, Elliot's just like, yeah, you don't actually have to use both of them. You could just do one of them, and somehow that'll work properly, just because of the way that it filters. I don't know though. All right, let's close this. But anyway, yeah, so that's that circuit, and that's how I'm utilizing that circuit. I think, and again, this is because of my reading through his various projects, he has a propensity to put a 33 kilo ohm resistor between things, between audio signals and stuff. So that's partially what's going on here. That's definitely what's going on here. So this line right here, straight down the middle right there, That's where that's where we're gonna put our EQ. Our EQ will go in there, and it's gonna consist of a bunch of op amps. I've been reading a lot of these different projects. I gotta actually look at my browser on the other computer to show you guys the. Fuck, that was a drop. I forgot that I wasn't looped into my belt thing. Hold on, let me get that stuff from under the desk. From under the desk. Action, adventure awaits. There. Okay, there we go. Let me get that stuff back. All right, so the projects that I started looking at were various EQs, and there's a couple different methods for equalizing that are in display. I wonder if this thing will show. Did I close my browser? What happened to it? No, there it is. I wonder if I could open these through. Well, anyway, project 150 is where I ended up. And I think 152 is the update to that. But anyway, let's look at project 150. I just do this. Wine Bridge Pan American Equalizer. Parametric. It's a parametric equalizer. There's actually a couple different equalizers on his page. Hold on, let's do parametric subwoofer. That's the original. The graphic equalizer, I think. Multiple feedback bandpass. There's 17 different equalizers on the freaking website. No. Linkwitz. Constant Q. Reverse RIAA. I don't know if I need that. Subwoofer. 78 RP. No. Not getting out my 45s or my 78s. Musical instrument. Wine Bridge. That's actually the one that we're going to look at. Constant directivity horn equalization. No. Low frequency boost and high pass. That's already in the mixer that I have. All right, Pilot. Good seeing you. Thanks for dropping in. Pilot actually was on the Amuga stream that I did like 2 years ago. Can we believe that it's been that long? Holy fuck. ABC NYE EQ. What the fuck is that? ABC New Year's Eve concert equalizer specific to Australia. And the muffled sound broadcast by the ABC. That's kind of funny. All right, so that's here are all the projects that have equalizers on them. Okay, so the thing about a panametric equalizer is that you're taking an audio signal and you're bussing it out to all of your devices, and all of your devices are listening to a particular frequency band of that audio, and then they are amplifying it or tamping it down in order to give you the audio that comes out the other end. So you can think of it like ... Hold on. This is the common amplifier circuit, by the way. This is how you would do your amplifier, and then there's actually a program that you can download that Elliot made that lets you determine what the frequency is and what the Q is, and et cetera, et cetera. Now, I've written all that stuff down. I've got that stuff in a text file, and I actually wrote it down on here I know all the frequencies and the Qs in order to give me this. I could try to replicate them as close as possible using fixed values. We'll probably end up using potentiometers depending on if I can fit them. But yeah, you would essentially build this using R1, R2, C1, and C2. I think R3, yeah, R3 just stays the same throughout. R2 does too. Beep boop boop wee, huh? So does R1. Okay, so maybe you're just doing the capacitors. Never mind. In order to give you all of the appropriate frequencies that you want to isolate and then boost or tamp, and then you mix them all back together. You put them all back onto the same line. But Elliot's gone through a couple different, that would be the graphic equalizer, right? But Elliot's gone, I said it was panametric. That one is graphic, I'm sorry. Graphic equalizer, right? Graphic equalizer, you have a bunch of different op amps that will then, or no, wait, is graphic inline? Uh-oh. I forget which one is which, chat. I don't know. Shit. This one is just, what is this one all about? RIAA. What the hell's an RIAA input? What? Photo input's quite high. Pre-equalizer network, complete passive frequency response to the curve of the network. R1, blah, blah, blah. Inverse the standard RIAA curve. Oh, it's a specific curve? I don't know anything about this. I don't know anything. Whoa, what the hell are you doing here, Elliot? What is this? Oh, he's building it into the microphone. Holy shit. Damn. At least we know he can use surface mount stuff. I love my surface mount. I don't know why people aren't more in love with surface mount stuff. It's RIAA for vinyl record players. Gotcha. I don't know anything about that. This is a subwoofer. What type of equalizer is this? 8-band graphic. So graphic is op amp into op amp. Panametric is taking them all out of one another and having frequency bands. This is the one that I was looking at, where you basically have you have equalizer filters, right? Each of these filters has a specific band, a specific cue that it's able to operate on. There's a little bit of overlap depending on how you pick your frequencies and your cues, and then you can pipe them all back together into basically a large filter out band. So you have your filter input, which is going through a unity amplifier just as isolation. All of your audio comes in and is then filtered for a specific frequency, and you have one 10K potentiometer on the end that can adjust basically its volume. What volume of that frequency do you want to hear, less or more? All that stuff then goes into another amplifier, and then it's played around with, and you get different things on the end there in order to make your different filtering. I don't know why there's also a bass and treble booster or lower, and then a volume knob. It's basically a whole guitar amplifier, but you can think of the frequency responses like this. This is a pretty decent representation of it. So each of your circuits gets the whole audio spectrum, and then on the output, it is able to, it's able to observe basically this bell curve for every amplifier. The one towards the middle is going to be looking at the most audio, but it's also going to be looking at very little audio on the, and we're talking about frequencies here. So we're talking about, low frequencies or high frequencies, however you want to adjust those. I have my own specific way of adjusting those frequencies. Yeah. And I would have to try to implement that. That drop off is almost just naturally what's going to happen. Number 5, I would have to probably put something to drop off that additional high frequency. But that is your graphic? Or is this panametric? This is graphic, right? Yeah, this is graphic. Sorry. I gotta get the terms straight, because if I learn them backwards, I'm always gonna say them backwards. And then I get to actually get to learn that I've learned it wrong. You guys ever do that with something? Do you guys ever do that with something where you frequently say the opposite of what actually is the thing? Like you dyslexic, like AM, like let's say you learn AM and PM and you learn AM and PM backwards. And so then you have to learn that you've learned AM and PM backwards, so that when you say PM, you have to go, wait a minute, it's AM. Sorry, left and right. Are you checking to see if it's actually your chat up on screen? Yeah. I decided to add one of these, so in the event that I can actually post 2 YouTube videos a day, and I decide to make a VOD channel, which I really should, because technically, like, it'd be nice if you guys could catch up on some of these projects if you wanted to. If you like my voice that much, You can treat me as your mukbang partner, right? Except I don't frequently break down into crying. Okay, so this is a graphic equalizer. Graphic equalizer looks at the whole spectrum, but we're filtering a bell curve of a specific frequency band. If you combine all of those frequency bands, what Elliot's showing here, if you combine all those frequency bands and you set them all flat so that you get your perfect frequency response out of your audio gear, you're gonna get a little bit of a wobbly line. I thought you'd frequently cry. Oh, you're mean to me. You get a bit of a wobbly line. I'm wondering, is he using MATLAB for this? Because these are nice graphs. These look good. You get a bit of a wobbly line, and your response is a little bit wobbly. Now, the average person is not going to really see that. It's not going to be like a make or break situation for most people. You're not going to be able to hear that. You could call yourself as much of an audiophile as you want. You can buy all of the expensive amplification equipment. You can buy $10,000 headphones. You're not really going to be hearing that. That is such a minor thing. And that's something to keep within context, too, when you're working on projects like this, is that we may be dealing with near studio quality equipment when we build circuits like this, but we are broadcasting at Twitch rates. Twitch is not, and we're broadcasting it at Twitch rates. You guys are listening to it on your fucking phones. Like, it's not going to make a difference. $1,000 in your pocket would be nice. I'm going to edit the chat cutoff because I frequently see cutoff text up here. I need to get it like right in the middle, don't I? If I take that and I just go beep like that, maybe it won't cut stuff off. I know a chat plugin would be great, but where were these chat plugins when I, oh, thanks for the follow. Where were these chat plugins when I Googled it recently, right? Nowhere, that's where they were. So I'm just using Chatterino on a Windows capture. TMKDK, you're following. So yeah, this is your graphic equalizer. The other type of equalizer, and I'm actually let me get rid of these old windows because these are all built on top of one another. The parametric equalizer, this one specifically being a wine bridge, is amplifier into amplifier into amplifier. So each amplifier is performing a whisper down the lane function of taking all of your audio frequencies, altering a little bit of it, and sending it all on to the next amplifier. We are going to have 8 amplifiers inside of this container. 8. And the reason for that is that I'm going to have 6. I'm going to have 6 frequencies, or 6 bands that I want to edit. And I will have to make sure to get the cues right and get all that other junk adjusted properly. So what I'm thinking is we'll probably have scientific precision, not op amps. We're going to have low noise op amps because we have to do that. But then we're also going to have potentiometers that are the type with a little screw adjust. That's like it's like a worm gear. It's like a blue box is what I'm thinking, but those might be too big. I'll get them out of the parts bin and we can take a look at the sizes of stuff. And then we need to try to find parts from DigiKey that have 3D models associated with them. But the wine bridge is important, I guess an important one, just because of the way that it's altering the audio. So we're going to try to implement this one, and I really think we should probably breadboard this first. I mean, chat went through the Herculean effort to actually send me stuff about 8 years ago. How many years ago was that? It was like 2016. Oh my God. They sent me this hot air station that sits in the corner there, and then they sent me a bunch of like generic parts that I could use in order to do projects. And the question is, do I have amplifiers that are good enough that we can actually implement this? Because I think I have surface mount versions of all the amplifiers because I bought them for this project, right? I bought them for my normal amp. And so my normal amp, we're going to be inserting stuff into. So I'll have to build another one of these boxes. I'll be able to plug into that. And if I cut a trace on it, we can run output and then back input in order to make our EQ on the prototyping board. But this is the very basic wine bridge, and it's got absolutely terrible response, and there's a lot of stuff about it that's really, really bad. If you supplement that with some op amps, though, you get a volume control, you get an amplifier, you get a signal path, and then you get your output. And there's feedback in that. You're basically adjusting the feedback, right? He goes on to play with the circuit, and he adds a bunch of crap that's not really needed. Now this right here, this first U1, that is, I believe, an inverting amplifier, and that's just there to invert the signal so that it can mix back in after the amplifier. But he goes on and on in order to build all this stuff, including having this weird... He's basically justifying his use of this extra op amp in this circuit. So now we've got 3 op amps on the table here, and that would be 2 per channel of this thing. But then, later on, he just says, you know what, you actually don't really need this. You're not going to hear the response from it. Adding a buffer improves performance. That would be U2, but is not essential, especially for a tone control. The buffer between boost and cut pot wiper and the wine bridge minimizes interaction between the boost cut pot and wine bridge. Yeah, so basically as you adjust this, the frequency is going to start moving around. So, it's not really necessary. So he goes on to explain, you know, the types of frequency responses and what values you can put in these devices in order to get the responses you want. But again, since we are in some kind of a ridiculous ARG, Project 150 is not the end of it. In fact, he goes on to do, not Project 197. I just clicked on that because it was the next response. 197 is not what we're using. I think there's Project 152 is what we're looking for. Let me close this and let me go back to the list. Back to the list. I lost the list. I lost it. So you guys are wondering what it takes to get the audio that I got. This is where we are. Now keep in mind, I'm considering this stuff like not from like audio engineering, like a total audio engineering perspective. I'm taking them as functional blocks, and I'm placing them together in order to create our ultimate circuit here. So 152, it's a bass guitar amplifier, but what this does is this highlights how these blocks go together and how to make them so that they function simply in a system with multiple frequency adjustments. So I'm not really reading a lot of this stuff. I did read quite a bit of it. It would be cool to put a vacuum tube in my audio system. Actually, what I'm hoping for when I do get the mixer running is that I can pump the audio through my vacuum tube amplifier into the mixer and give you guys an idea, maybe a little idea of what that sounds like. It doesn't sound much different from regular audio, though. And you kind of need the good headphones to go with them. Yeah, I'm going to sound like a guitar. You don't necessarily, look, audio, I could put myself through a bass guitar amplifier. That might sound good. You just have to adjust it properly. Op amp, preamp. Well, I don't think we're going to do an op amp preamp. There's a pre-EQ, a B&T, and a tuner. Putting together these circuits is going to be kind of weird, huh? So this is like bass and treble adjustment. We're not interested in that. We are interested in the wine bridge EQ, which is a parametric equalizer. And these right here vacuum tube amplifier, not really disproving the audiophile label there. Look, man, I basically I wanted to know what it sounded like so that I could actually tell people they were touting bullshit when they were saying that vacuum tube amplifiers sounded really good. I wanted to tell them that they're a bunch of assholes for saying that. And so I bought an entry-level $120 vacuum tube amplifier, and I was wrong. It sounded amazing. In addition to the fact that it's kind of cool to have this little vacuum tube sitting over there producing your audio, because they've got little orange glowy lights in them that are the heaters. And so you've literally got a barrier, which is the gate pin, an anode and a cathode that are being baked, and the electrons are baking off of it, and then your gate will limit the amount of electrons that get by. It is something that exists just in three-dimensional space, and it's this big thing, and it's actually kind of awesome. It's kind of cool to have something that special and old and unique running your entire audio system. And then you get to go shopping for different vacuum tubes. So you get to go on eBay and look at old Russian stock of weird old stuff. Like a MOSFET, it's yeah, but the A triac it's a bit fundamentally different, but it does a lot of the same type of stuff. Why did my Twitch get? Oh, okay. Maybe I should snub those messages. We don't need to know what Chatterino's up to. I'll snub them later, I guess. Can I, like... There's like a reconnect command. Oh, I want to dox my my login thing. Let's see. Ignores, filters, highlights, accounts, nicknames, commands. Where do I do that? Huh. I guess I could snub the Twitch server message, but all right, I'll just leave it alone for now. I don't know why it's doing that. Anyway, yeah, you guys actually get to learn how slow my chat goes. I love the vacuum tube amplifier. I'm not an audiophile. Listen, I know stuff that sounds good, and I did spend, God, I spent a lot of money on my system that I use. I buy stuff from Shit Audio. I'm not even endorsed by these fuckers, and here I am going, hey, look at Shit Audio. These are cool. These are not incredibly expensive. Here's a $100 headphone amplifier. So if you buy expensive headphones, you'll want to be able to drive them properly. You can buy something like this, or you can get the vacuum tube edition of the same thing. It's not an unfortunate name choice. It's literally what they decided to call themselves. And they lean into it. Because what I have is a shit stack. I got a shit stack with one of these. This one was $350. It was the Trump check bought me this. I wanted to upgrade my system because I got good headphones. If you guys saw me last stream, you saw my headphones. No, I wasn't on Facecam last stream. Stream before last, you guys got to see my headphones. Yeah, they lean into that. How's it sound? Like shit. Some of these get really expensive, but then again, you know, an incredible audio power amplifier is an expensive thing. So you could get the Modi, and then you could get the you could also just get the full. You get the Modi and the Magni, right? You get those two, and you can drive really nice headphones on them, really cleanly. And the reason that you would get the reason that you would get the Modi would be to separate your sound card away from the rest of your system. Personally, I have this one. I got the Modius, and I got the I keep clicking on the wrong thing. The Modi and the Valhalla too. It's an absolutely brilliant system, and I love it to death. But yeah, these guys, they also sell, you know, affordable, high-quality audio stuff. So if you really wanted just like a gaming headphone amp for your really nice gaming headphones, there you go. There's the thing right there. That's probably what I should have originally gotten anyway. The products did not exist back then. Anyway, yeah, Shit Audio, really good. So besides that, I think it would be cool to pipe my tube amp over to you guys during the game streams, but at the same time, you're not going to hear that. You're probably not going to hear the difference. You're probably not going to hear the difference. In order to make that amplifier work properly for me too, I had actually researched getting the right tubes, and there are some long life General Electric tubes that I put in there, as well as some Russian tubes. So we got the USA and the Russians working together, as well as converters for the pinout of the tube, and an offset thing. It's called a socket saver, that moves the tubes up a little bit, and so the whole unit is much cooler with the tubes a little bit outside of the case. It's weird, but I love shit like that, so I don't know. Anyway, we're not doing a high-pass filter. We're doing filter blocks. Well, all right, fine. The filter blocks will look like this. And although this is his low, mid, and high, this just shows the circuit. There's I think it's 152.2 maybe, in the write-up, where he actually shows the the graphic equalizer, or sorry, the panometric equalizer. Where is it? Where'd it go? Show me the equalizer. Ah, damn it. Of course I can't find it. Of course I can't find it. This is all stuff related to the guitar amp, so. The hell? Oh, effects send and return. Neat. I've zoomed in significantly. That's why everything looks weird. Zooming in for stream. Somewhere or other he explains about how he's got multiples of these things strung together. I'm just not seeing it. Oh well. Anyway. I really should put something like this in there. Do a valve preamp on my belt. Ow, the tube is hot. Ow, ow, ow. All right, anyway. So what we're going to be building are these blocks here. Not that one. This one down here. And we've got to appropriately select the different stages. Now, what did I write down? I wrote down project 152. Where did I get that block? I guess I wrote down this block here. But it's like the different frequencies have different resistor values on them. Just find some glow tubes. They do nothing but have an LED in them. Ha! I actually do have two tubes that are magic eye tubes. Build a Butterworth filter. What was the type of filter that I was looking at with the what was that called again? Hold on, it was a Discord conversation. I should be able to pull it up if I go down to the stream projects. What are we talking about? Biquad. Yeah, if we went to the I2S. Hey, Aaron Peril, how you doing? If I went to the I2S audio converter to FPGA to I2S back to analog thing, if we put it into an FPGA, I would have to calculate coefficients for a biquad filter, which is insane. Insane. Absolutely fucking psychotic. The transfer function is right there. I'm sure you guys can very easily calculate all the numbers associated with it for me. It's pretty, yeah, it's just intuitive, right? There are online calculators for these things, but yeah, this is how I would adjust the frequencies and stuff and do some advanced filtering with digital audio techniques into an FPGA. I think that would be a really cool project to do, but it's kind of biting off a little bit more than I can chew. I'm not totally sped up on how to FPGA properly. I have absolutely no idea. Like, okay. Some weird shit going on there. Anywho, yeah, we're going to build a bunch of these, and those should hopefully filter the audio. I got to make a decision here. I mean, we could jump directly into building the circuit. Calculating the coefficient really is the most difficult. Thank God for smarter people making tools. Yeah, but the problem is I can't find like a 6-band EQ tool in order to make the biquad filter do this. It would be nice if I could do this to the fucking thing. But all of them allow you to adjust one frequency and create one single band, whereas I'd need to go with 6 in order to recreate that, which would be super cool to do. But yeah, anyway, it'd be crazy having an FPGA just like doing a digital audio workstation thing inside of this tiny little box I can't reconfigure. I guess I'd have to make it configurable over USB. I don't think I have a high-pass filter, no. I'll have one on the new one. I guess I have a low-pass filter. Yeah. This is it. I have this in the compressor. This is my whole audio system. And I think I turned off the noise filter from OBS. So, yeah, it's just these two doing the work. That's why my audio sounds the way it does. There might be something up there. I just can't see it. We can zoom in. Can't really zoom out, and I can't go back and forth because I think that bar is covered by the UI issue of me not upgrading the tools. I should probably upgrade that to the latest version, but... You're thinking I should sum the bands. The good thing about summing the bands is that all of the stuff isn't in there still. FPGA OS only locks gates after you've programmed them, just like an ASIC. Well, I mean, the thing is, like, I don't know, you plug it into USB and I guess be able to reprogram it somehow. I mean, it doesn't, like, some of the, like, the filter values and stuff you could probably have in there to change. It's not, look, when I say FPGA, I don't mean strictly, you know, the first FPGA ever invented. They've got more features on them nowadays. But yeah, this is what I, you know, I got 5 bands here. I was thinking 6 because I could do the high cut. Or I could just leave it in. So I need 6 of these circuits, which means I need a lot of components in order to put this thing together. I think maybe we should breadboard this thing first. I think that's probably a good idea. We breadboard it first, and then I can, and then we can test it and see if it's the right thing. I have a feeling it is the right thing, but I would like to, you know, have a good, take a good stab at it to make it work. The only thing that I don't have are these dual gang 100K pots. These are supposed to be connected to one another, I believe. I don't know, they're separate on this one. I don't have the page open. Man, come on. You're taking it into I2S. And then you're putting it back out to I2S. I'm not... I just like... I'm not dumb. Come on. You basically have a chip that turns analog audio into I2S. You send the bit stream into the FPGA. The bit stream comes out of the FPGA, and then you turn it back into analog audio with another I2S thing. I got all the components sitting right somewhere back there. But we're going to use op amps at first, at least. I'm going to give it a try. So... I don't know where he has this in another form, because I don't know if this is the one that I followed. It seems to be the one that I wrote down. And are those two locked into one another, or are they separate? He doesn't really make that very clear. They might be separate. One of them is frequency, the other is Q, and then this one is the gain. Right? Let's make sure. Circuit shown, straightforward, doesn't need 4 op amps for each frequency. That's good. You don't have the ability to modify the filter Q, but that's not usually an option on bass amps. Modifying the filter Q. Now my Q across the filter, 0.57, 0.76, 0.44, 0.85, 0.47, 1.44. 1.44 is just for that cut at the end. Those are the 6 that I have. So if I don't have that 6th, if I don't cut it at 20K, which it'll cut anyway, then I'll have 0.47, 0.85, 0.44, blah, 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 blah. They're all about 0.5 for the most part. The only one that I've really significantly altered is number 5, and they are approximately at each whatever it is, what am I trying to say? I don't know. They're separated appropriately, evenly across the audio spectrum. I could live with the original, whatever Q value this thing has, and possibly get by. 2 mid-range parametric sections that will usually be sufficient, especially in combined with frequency pass. He's specifically making this for his bass guitar, so I'm making this for voice amplification. There's no reason it can't work for both. So each parametric section's frequency is tuned with a dual gang pot. There we go. VR3 and VR4. Dual gang. So we do need to find... Wait a minute. VR3 and 4. Oh, yeah. 3 and 4. Those aren't dual gang. They're dual gang because it's VR3 A and B. There we go. That's what I was looking for. Usually he drew like a line between the two, but in this case he calls them A and B. So we need to find a dual gang pot of 100 kilo ohm flavor. Through hole at first. Now, I know I don't have anything like that. So we got to order it. Potentiometer. Potentiometer. Rotary potentiometer. Rheostats. Trimming potentiometer. Slide the potentiometers. This is the kind that he thinks we're going to use. But he would be wrong. We're going to use screw ones. We got kits, we got knobs, we got power resistors, we got gadgets and gizmos. What the hell? I gotta see what it is. The foot pedal pot. Okay. That's a gadget and gizmo from Adafruit. Aha. That's why they have that category. Get out of here. Blah, 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 blah. All right, so what we're looking for is potentially, I would say, a trimmer or a rotary. Now, if it's rotary... Man, what are those called? Those little scientific square ones. Let's see if I can pull one out. Let's see if I can pull one out on you. I think I still have a couple. Maybe not. I don't know. We'll see. Let's see what I got in the bins here. I got the bins. Got the bins to prove it. Literally all of my bins are out right now. Jesus. It doesn't look like I got anything. That's weird. I could have sworn I'd been swimming in those things previously. How about you? Yeah, here's some. Here we go. I do have them. I wasn't lying. They're going to have to be something else in terms of smallness. That's the problem. For now, the through-hole ones will do, but I am going to need dual gang versions of these things, and I will need super-de-duper small trim pot ones. These used to be shiny. Looks like they've corroded over time. These are great. These are like scientific instrument kind of amplifiers. You see these a lot in like expensive stuff. But you use a tiny little screwdriver, Exhibit A, and you can just adjust this thing right here, and it's basically a worm gear with a turner inside of it. So they're very easily to precisely align. I would like to use these at least in part of the design. Now, 100K ohms, that's a very typical value. I have a feeling that some of these are in fact... What's that one? Looks like I gotta look it up, because it says 503, which might mean 50K. Something like this would be evil. This would just be completely evil, because this thing is very loosely adjustable, and it wanders around, and it scratches and stuff when you adjust it. And those little surface mount trim pots are just, they should be categorized as a war crime. So anyway, this is the type of style that I'm thinking for them. At least also for the, we can get, hold on, I'm gonna cough. We can get this style because they're 0.1 inch spaced for the breadboard setup. I dropped that into the wrong bin. Okay. All right. So the question is, what is that? Is that a trimmer? Nice. Lots of good photos here. Lots of good photos. In stock. Photo. We're not checking this one yet. Mostly if it has a photo, it's the right thing. I hate all of these. I hate all of these. The problem with trimmer pots controlling your device is that they're not easy to use, and they suck. Like, they're just bad. Okay, so that is technically a trimmer pot. Yeah, so we can find that style all over. I like this style because it has a very decisive little adjustment thing on it that's hard to tamper with your hands, and it holds its value because it's a worm gear. These are the good stuff. I like these. All right, so let's see. We need a 100K, so let's put the value in just because. 100K. Don't care about it, don't care about it. We might want 5% tolerance on the thing. Although it is an adjustment, so I guess it can have bad tolerance. We don't care, well, the number of turns we might want, but the adjustment side, let's not look at that yet. We want through hole. What else? Series, packaging. Oh, packaging. Yeah, I'm not really sure which ones to choose here. Basically, I don't want anything that's bulk, so like a tape and reel I don't need. If I select like tube, cut tape, box, and bag, now we've gotten rid of the super duper bulk ones. Wonder if it'd be feasible to do something with a microcontroller driving a multi-output DAC to replace the trim pots. You can get digital pots. That would be a weird thing to get, though. I don't want them in SMD version. I know I can get these in an SMD version, but I might need to get something smaller than these, because it's going to be hard to fit 12 to 20 of these things into that little case. Apply. Only 65 choices remaining, which is getting a little bit worrying, because these don't attach to one another. And these look like singular potentiometer versions. I don't think I'm getting a dual pot out of this. Which I guess, you know, I could move them together. I'm doing panametric. I don't know if the graphic equalizer... Does the graphic equalizer require... Oops, what? Okay. Because this is the panametric equalizer right here. So I can run this circuit into itself 6 times in order to get my 6 bands, or I could go to the this is panametric. This is panametric. Yeah, well, that it just displays a little bit about the panametric there, because these are the values that I could use. These have close to the right frequencies. What happened to the graphic equalizer? Hold on. ESP projects. Let's bring that all the way back to the beginning. Close that. Control F. Graphic. That's an instrument graphic. Constant Q graphic. Subwoofer graphic. Musical instrument. Maybe that one. This one would be... Yeah, this one would be the graphic. But he uses FETs, but he's also got a version of the circuit that uses op amp. Or rather, transistors. So I could do this one too. Welcome to the chat room. What the hell is going on with Twitch? Why am I getting logged out of my own chat? Jeez. This one would use less large components, in addition to the fact that it doesn't need a dual pot. You have a 10K going into a 22K going out. So this one would be more parts friendly. I'd have 6 of these adjustable potentiometers, which I could fit very easily into the circuit. And then it's literally just adjusting the volume of these. And if I wanted them to be adjustable, I think one of these becomes a trim pot. Let me look up. I think there's a different circuit for his EQ that is a little different than this one. Not the subwoofer. Maybe the constant Q. Constant QQ. QEQ. QED. Maybe. Yeah, this is one of them. What don't I know? I thought the dual pots on the Wine EQ was for different bands. Each section's frequency is tuned with a dual gang pot. So yes, I could select the band with resistors, and then just use have the only potentiometer be the boost or tamp control. No, they're dual pots. So it's not 4 bands. Can't modify the filter Q. Each section's frequency is tuned with a dual gang pot. Q remains constant. Frequencies is variable as the frequency is variable. And as shown, each section has a 12 dB range. Because of the number of stages, low impedance are used to minimize noise. Circuit shown is not quite well behaved, as well behaved as the alternate version with buffers, as described in Project 150, but it's simpler and it's highly doubtful that you'll hear any difference at all. This is something that happens when you drill down into the text. You need to really drill down into the text to get those little details like that. The downside is that the frequency pots are 100K, so they may be small. Maybe a small increase in audible noise if you use maximum boost, which by God I will not. The gain on all of the stages of this thing is like barely. The max gain that I have is about 1.41. Actually, it's 1.41 on 2 of them. Max gain is 1.41, and my max negative is 2.44. And this thing's talking about like huge numbers. 4 times, yeah. I could put a high pass filter in it, but I'm not gonna go crazy. Man, if I was gonna go super duper tiny surface mount, I could put all kinds of shit into this thing, but I want it to be simple and adjustable. I want to keep the surface mount devices simple, and I want to make sure that I can tune it for my 2 different mics. I did a lot of homework on this, yeah. I have the advantage of having actually read the text, maybe not retaining all of it. Part of it is also that we're just going to jump into the ocean here. So my choices here are whether or not you should put... I think there's a high-pass filter on the mixer, so... I don't have space, you know? These are physical devices that I got to get into this thing. Unless I, like... Probably spelled that wrong. Also, it's probably listed as like... Dear God, that's huge. I don't even know what this stuff is. Oh God. Audio special purpose ICs. Ah, Renaissance. What is this thing? Audio channel. SCF type fixed equalizer. Do I have a data sheet? I don't even know where it starts. Audio processing EQ. Okay. Audio EQ. I don't know. Everybody's going digital now, so I don't think I'll be able to find anything. Amplifier. This is literally just an amplifier. God damn it, DigiKey. I'm wondering if there's like an ASIC that does all this filtering stuff. I guess there probably isn't. Look, we get to take pride in the sweat of our brow putting together a complicated circuit. I just don't think in the size that I want to build everything. Why is there always a cutoff on chat? Why is there always, like, I've tried to get rid of it. Whatever. I can't win them all. I could always have like I could always move chat to where it touches the top of the screen. Oh, I can't because of the snaps. There. Now it's cut off by running into the top of that. Analog devices have a filter generator tool online. I think Fat linked me to that. Yeah, there's you can make all the filters that you want. We're gonna follow this thing, even though chat's trying to like puppet me. We're gonna follow this thing. So we're gonna take the signal out of the electret microphone and we're gonna pipe it in to these amplifiers. I don't think we need the unity gain. I don't think we need the unity gain amplifier at the beginning. We'll find out, but Yeah, that's the one that you linked. That's a very simple page. It's very good. Very well laid out. We'll see if I need to call upon that later. Hopefully not. So yeah. I'm gonna put 6 of these things in line with one another. And I guess maybe we could make one and test that out. I don't have the dual gang 100K pot though, so we gotta find something that's gonna work in lieu of that. The problem with this one is that we need the dual pot. And if I do... That's for the wine bridge? No, parametric EQ, which utilizes, I guess, the wine bridge amplifier. Yeah, the wine bridge circuit. It's a modified version of the wine bridge circuit right here. And you can actually fix those frequencies. This one has the dual pot. It's just laid out a little differently. So basically what he's doing is he's getting rid of the initial inverter. Now, what is that doing? Do I need that in there? Simply add an extra resistor, increase the gain of the op amp. Hep's filter Q doesn't have any ill effects. Be warned, you make value. Okay, so where does he first introduce that? Full minimized circuit for a single band is shown above. Because the circuit's inverting, we need an inverting buffer to drive it. This ensures that there's no phase reversal. But of course, if you use 2 circuits, then the buffer must be non-inverting. The input of the equalizer must be driven from a low impedance source, or the cut boost control will be asymmetrical. The frequency control pot is a dual gang type, and both pots are linear. R5 is only shown because it's used in the next circuit. So if you have 2 circuits, Jesus Christ. Okay. If I have 6, then I don't need the inversion on the end. Right? I guess? I don't think you need a buffer in between them. Circuit is inverting. We need an inverting buffer to drive it. This ensures that there's no phase reversal. But of course, if you use 2 circuits, then the buffer must be non-inverting. So we would need to have a non-inverting buffer here. Jesus Christ. It's complicated. Yeah. I guess we just get audio out the other end, though. So anyway, what's going on in our original project is somewhere around here. What's going on in our original project is we've got the electret microphone section here, and we need to put in our panometric section. So let me do that up in MS Paint. I don't know what program this guy uses to put together these schematics, but they're very good looking like this. I do this kind of stuff in MS Paint. But we'll keep it in his style, just so that I get a record of what I want to put together. So I'm going to take this entire image and place it in here. I'm going to take this guy, place it in here. That's what I'm going to work from. So let's take this circuit, copy it, paste it. Now, obviously, I've done this on the notebook, but uses MS Paint and a really old CAD. Yeah, those old CAD programs, man, they make good-looking circuits. I like the simplicity of it. What in the goddamn fuck is that message? Did your bot break? What's going on here? Hello, bot. There are many great free CAD programs. What would I do without you? What would I do without you? All right, let's get this. So this is the cutoff right here. That's where our circuit go. So our audio is actually going to go in right here. Oh, usually I like to use big, thick lines, but we'll try to preserve the style of this. So this right here is our audio input. And what is that doing? That one goes back to the other filter. I don't know what's going on there. I don't know what to do about this line. That simply goes into the plus on the filter. Is that another audio line? No. But I mean, it is our reference for the plus. I don't know if maybe I need to just connect this all the way to the other one. That's a little bit of my debate on this one, because I know positive and negative 14 volts are on the two input lines to everything, right? And then that gets, so that's pulling down from there. This one is going down the ground. No, this is not a low pass filter. What this is doing is this is inverting the signal. This right here is inverting the signal so that I can go back onto the differential line. Protel and Symmetrics, and also Paint. Huh. Because, yeah, these are the outputs to Phantom Power, audio outputs. So this is creating the inverting signal, and might not even be necessary according to his schematic, or according to his what he says. But anyway, my thoughts are that that is where we want to do the equalization. So our audio output here. What? I thought I selected. Ah! Is it like slightly off-white? Is that what I'm dealing with? Why is this not transparent? That's so weird. It must be a slightly different shade. Whatever, close enough. So what I'm thinking is that our stuff goes here. I didn't have to get rid of the dot. Oh well. There we go. So yeah, that's where we would put everything. I wonder if that's like a virtual ground or something. I don't really know. I don't really know what's going on there. I don't have a full understanding of this. Isn't that the high side? You sure the EQ can handle the voltage? No. I have no idea. That's why we do tests. I thought that this was just amplifying the very small electret microphone signal. Let's go back to the text and see what kind of an explanation we have and see if my theory is correct. But if I always listened to you guys, I wouldn't get shit done. God. Project 93, we just have that open. Yeah, I closed Project 93. Elliott Sound, Project 93. I have the benefit of having read about all this stuff and forgotten it. Purpose of the article: small group projects firstly introduced the electret microphone, ESP projects light up cellular microphone. Traditionally, measurement of microphones are calibrated so that the exact output levels for a given SPL is known. Blah blah blah. The measurement of the project is not calibrated for level of response. Tram TA50 TR data sheet. There is the tram's response. The tram TR50, and here's what I do to it. I'm a monster. Look at what I've done. Look at my boy. Look at what he's done to my boy. My baby boy. My God. All right. So yeah, that's the TA50, and this is why, up here is why you can hear me do this on the microphone. It's ridiculous. The high frequency response is insane. In addition to used with wireless, TA50 uses a low impedance hardwire microphone with a TR79 power supply. It's basically a transformer. It's a good little mic. I like this thing. I bought a second one for $150, and I probably should get a third. It helps to have backups of stuff, but that's cheap considering the cost of some of the microphones that people use on Twitch. Dear God, people spend upwards of $1,000 on their audio. So I mean, freaking like Sickab bought a $400 microphone. He sounds good, but those are condenser microphones, and they're ones that have like built-in compressors and stuff like that, so they sound really, really good for voice. I have to do all this tuning because I'm a cheapskate. Catchy. Figure 1 shows why they look how they look like. And typical frequency response, Panasonic capsules. Oh, I did actually read that right. I thought you said parametric. Panasonic capsules and response are shown, but this is also typical of many others. Really? Mine does not look like this. Digital microphone projects will be presented, blah, blah, blah. Sensitivity. In some cases, sensitivity of mic will be expressed by a manner that doesn't tell you a thing. Given specification of 69 dB is simply pointless. Nice. As such, must be ignored. Blah, 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 blah. Blah, 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 blah. Traditionally, electret mics are powered by a 1.5 volt cell. So we're getting away from that. Listen, I had a cardioid AT2020 Plus for many years before we went on the lavalier microphone path. I know the stuff that you guys are trying to tell me. Hey, Uncle Phil, I know these things, guys. All right. Octar is not usually used. Blah, 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 blah. So he's talking about how to put it all together. CUI condensers are a bit better. Look, man, I'm not going to a condenser mic because I don't spend my whole... Well, today I'm spending my whole stream on my fucking ass sitting here talking to you guys, but generally I'm up and about and moving around the shop and working on stuff. Father, did you know that you use a lavalier microphone because you move around a lot? Thanks. All right. So what we're doing is we're drilling down to the text and we're trying to figure out why is what is where on this circuit to see if I'm wrong, because chat will not allow me to say something without challenging every single thing that I say. Every single fucking thing that I say. Actually, Bother, you could use a different CAD program if you fucking tried, you dumbass. Fucking streamer, I hate him. The disadvantage center method is usually this one advantage. Normally available from retail outlets cheaply. The disadvantages cause some mics to have poor reputation. Blah, 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 blah. The point is I needed to pin something on my chest. So note the supply voltage increase, feed resistance also decreased, blah, blah, blah. Doing so, output level low advantage remains. Can't change that. I've used a modified hypercardioid electret mic, which cost less than $50 at the time, achieved excellent results for recording voice announcements in a professional capacity. In many cases, the quality was better than that from several recording studios that have been used previously. The original mic was housed in a plastic case with zero shielding. I did a bunch of stuff to it. I was able to get it to work with a 9-volt battery. I don't know anything about audio, so I won't backseat. Man, we get people coming into the channel like trying to teach me what a resistor is. Like, it is the curse of having engineers as an audience. Having written for Hackaday, I know. Simple remote power microphone schematic. You can be very simple with these things, right? Standard off-the-shelf electret may not be calibrated, but typical inserts will be acceptably flat from 20 to 10 kilohertz. See, I don't want flatness because we're doing broadcast voice. 3 dB rise at 18 kilohertz before rolling off again. 3 dB rise at 18 kilohertz. Okay. Actually, that would be here, right? No, 18 is up here, yeah. That 3 dB rise. 0, 5. Bonk. Wow, well, fancy that. That looks a little familiar. It looks a little near and dear to what we're talking about right now. Going to my Jim Henson voice. Yes, sir. Yeah, 18 kilohertz, 3 dB. Neat. Off-the-shelf Electret mic. How dare you? How fucking dare you? Typical response graph shown above figure 1B. It's obviously impossible to guarantee that the one you get will be the same. It's unlikely it'll be widely different. All right, anyway. Photo of my prototype probe. Ew, what are you doing with that? Ew, ew. Ew, what are you doing with that? Ew. Long tube ensures minimal diffraction interference. That's not, I mean, I literally have it pinned to my chest. Figure 4C above. Blah, 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 blah. Does it sound like I'm in an echoey room? It probably shouldn't, right? I know with a lot of mic setups, you get a lot of echoes coming back. What does Electret mean? It's actually explained up here, and I need to look. I don't want to say the wrong thing, because then everybody's going to jump down my fucking throat. I think Electret is a type of capacitance plate, right? Project lineups, measurement microphones, calibrated, not calibrated. He doesn't really talk about that. Let's go straight to Wikipedia on this one because I don't want to jump the gun about it. Electrostatic capacitor-based microphone, which eliminates the need of polarizing power supply used by permanently charged material. Electret is a stable dielectric, so it's a type of silicon with a permanently embedded static electric dipole moment. So I was going to say that. Due to the high resistance, chemical stability of the material does not decay for hundreds of years. They got plenty of time with this microphone. The name comes from electrostatic and magnet, drawing analogy to the formation of a magnet by alignment of the magnetic domains in a piece of iron. Electrets are commonly made by first melting a suitable dielectric material, such as a plastic or wax, that contains polar molecules. And then I lost the thread of that. I'm not thinking about what I'm saying anymore. I don't even know these words. Anyway, yeah, so that's the Electret. It's just a capacitive material. We need to give it energy in order to make it output a voltage level signal. And I was just reading words at a certain point there. You can buy these from this guy, by the way. But yeah, anyway. Figure 4C above shows the preamp looks like. Pressure zone microphone, I don't care about. All right, the project. Let's get into this. Figure 6 shows the project preamp, balanced mic line driver. This is suitable for use with phantom or battery power and is easily adaptable for either. You don't want to put phantom power into a battery, though. That's one thing. Reading my smooth broadcast voice. I try. Man, it would be cool to get gigs like doing actual broadcasting. Hello and welcome to Movie Phone. I don't know. I don't think I'm quite good enough for voice acting. A lot of it has to do with the filtering on the outside of my voice here. Being a big fat guy means I guess you can make a lot of cool voices. I don't know. This preamp is a PCB, which is available, suitable for use with any microphone shown in the article, suitable for measurements or recording. High output, low noise, may be powered by a 9-volt battery. Phantom power for 30 to 48. Load resistance impedance should not be at least 1K. This is actually considerably lower than most preamps, so will not cause a problem. Boop, 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 boop. Preamp is very similar to the DOZ preamp. The fuck is that? What the fuck is that? There's no link. Maybe there's more information on this. It's another Elliott Sound project. This is what I'm talking about with fucking Elliott Sound. Look at all these tabs. This is the minimum number of tabs to start getting into Elliott Sound projects. Preamp is designed for the minimalist, having no frills, and is all the design goal for this project. Hey, that's nice. It is designed as a preamp for the death of Zen. Class A Power Amp Project 36. We're getting lower in numbers here. There's very low levels of noise and distortion and a minimum component count. Fully discrete circuit. The gain module can be used as the basis for the preamp. Performance is exemplary with low noise and bandwidth. What I'm trying to do is figure out how he designs stuff. This is part of like reverse engineering circuits that I did for the government. This is the kind of stuff like where I'm looking at his other designs in order to figure out how he likes to design stuff, and that'll help me figure out where I'm supposed to staple parts of his design to other parts of his design. My theory right there is that I can probably split this whole thing in half and then put our stuff in the middle. I don't know what this is doing though. This might be some type of virtual ground. I don't know. So I have to get to the bottom of this. The other part was like, where do I... Oh, I guess both of these are the same power. Yeah, because it's the same op amp. So yeah, you want to connect them here on those rails with 33K to positive and the 100 micro to negative. And he's got the same similar thing over here, but he's got the 100K going into it. The circuit loops in this thing are making me busy. Yeah, this is my very special CAD program. I don't know if it's available to everybody though. It's kind of tough to get a hold of, but yeah, this is how I do schematics. This is how I do schematics when I'm not using Fusion 360. Now, eventually, we are going to go into Fusion 360. I already did the fun stuff that we should have been doing today. What really sucks is when you get bitten by the bug of a project and you can't stop yourself from working on it. And I apologize to you guys because this would have been somewhat of a fun stream, is putting this stuff together. A lot of the coloring of these components was the not fun part, but the fun part was coming up with the absolutely psychotic sketch that makes out the shape of this extrusion. Absolutely ridiculous, the amount of stuff, the number of boxes that had to go into this somewhat symmetrical design. But now that I've got this put together, I am going to be able to design a circuit board that will fit, because I've got all the stuff in here. The one thing that's missing is wires that are soldered to the pins. Yeah, the end result looks really fucking good. I'm super happy with it, and it represents almost exactly what is actually there. So, I've got a call from Delaware. My phone's not very loud.
Not gotten a response. We are giving you a final courtesy call before you close out your file. Press 2 to be removed and put on our do not call list.
They're gonna close out my file in the dealer services? Oh my god! Alright, anyway. Fuckers. We're calling you about dealer services. I own a 1999 BMW. There are no dealer services. No, not for that car. No. Oh, do I not have chat on this window? I should probably add chat. Let's go here. Let's steal you guys. Wait, is the shadow different between this one and the one on... Yeah, it is. I need to take this one actually. Hold on, I gotta fix my setup real quick. Yeah, I'm gonna delete you guys here. How do I delete that? I guess I click on it and I hit minus. There we go. You guys die. You're dead. I killed chat. I deleted chat. I deleted chat, and I'll do it again. Anyway, I gotta get chat from, grab you guys from here, and I'll move you over to the other one, but I gotta rename my group. Rename to chat. There you go. Let me cut you. I'm gonna cut you, chat. Never mind, just copy. And we'll go to face, and I'll paste it in as a reference. Move you guys down below this stuff. There we go. Is that a good place for you? I mean, I could put you like right in front of me, but I don't know. I think that draws the eye over to the other parts of the shop a little bit better. You can get the contrast off of my shirt. We don't need you on Burn the Subs, and I don't think I'm going to put you guys on the microscope. I think on the face cam is okay, but then when I zoom in, it'll go away. That's okay, though. Yeah, maybe you guys are better off over here. Oh, no, that's way too much bright, dark contrast. I could put you up here, but then you guys can't really, like, see all the cool stuff on my desk. Actually, I need to clean up my desk. I need to clean up my desk is what I need to do. Where's the overlay on this scene? Or sorry, where's Streamlabs? Streamlabs is up there. So yeah, you guys will be on the opposite corner. That'll do. This is the most stress-free option. You guys are on thin ice, all right? We probably deserved it. No! It would be kind of funny if I did face zoom and it zoomed in on whatever chat messages are there. I think Milton does that. I don't want to steal his jokes. Got to get timed out, animal groin. All right, anyway, yeah, so I made this comprehensive model of the thing, and this would have been the fun part. But all this stuff, we're now seeing what I want to test going in. So we've got to get into the text of of the Elliott sound project so that I can see whether or not we can paste our stuff right in here. And the circuit that I had previously made, the one that you're listening to right now, is basically this circuit, but not without the filters in the middle. I'll steal everyone's jokes. Tomato fucking hates me anyway, you know, whatever. Whatever. He's talking about hanging out. I don't hang out in any chats, unlike some degenerates, and I'm like, oh. Like, oh man, come on. Go easy on me today. Anyway, preamp design for the minimalist, having no frills. All right, so what did he build here? Because that's what I'm curious about. This is the precursor to the lavalier mic setup. What the hell is this? This is like a mixer. It used to be very difficult to build circuits back in the early 2000s. It used to be very difficult to build circuits. There were barely any tools that you could use in order to put together your CAD design and make a cheap circuit board prototype. And so this looks a little bit hand etched, which is fine. I'm so glad to be moved away from that era, because now we can get professional PCBs for just dumbass ideas that we have, as long as we're willing to wait like a week or two for the boards to come in. I love it. I don't want to go back. I look at this kind of stuff and I'm like, bleh. So I don't know how much information I'm going to get off of this. I mean, it doesn't look like he's using op amps in the circuit. He's got in and out here, and then he's basically built a transistor amplifier. Let's push pull, and he's got a virtual positive. That is just ground. Getting heartburn, one sec. D1 and D2. Filtering that. I'm looking for circuit loops here, man, and I'm just seeing a mess. Yeah, it's got the 100K trim pot on it, too. Well, this is the precursor, right? Minimalist, discrete, high, yeah, whatever. I still have the etching bath somewhere. I never did that. I did it once, and then I was like, well, what do we do with the chemicals? Like, these are some pretty gnarly chemicals. It's very similar to the DOZ preamp. The topology is identical, but it has been modified to use a lower supply voltage. The amplifier is a single-ended Class A current feedback circuit, which is good linearity, wide bandwidth, unconditionally stable. Ferrite beads F1 and F2 are recommended on the outputs. So you didn't even do that for the one that I had. So 9 volts in, electret positive and negative. The 10K, the 100K, 10U, and then that. I remember that from the op amp circuit. What's up, Veronica Gear? How you doing? And now I'm back here. Hey, oh yeah, Cosmo Quest rated. Hey, how you guys doing? We're looking at amps right now. Oh boy. Sorry, I'm in the middle of text. Well, actually, okay, I am in the middle of this text, which is in front of me. The Cosmo Quest raid text. Yeah, we're looking at, so this is the circuit, literally this project right here. This is the circuit that's taking my microphone and amplifying it using phantom power, and then puts it onto the audio that you guys are listening to right now. We're actually we're testing out a little chat window so you guys can be a little less toxic for once. Even though you guys aren't being less, you guys are being more toxic now that I have a chat window up. But yeah, so this is my amplifier circuit. This is what sits inside of the little box on my belt. I did the fun part already, which is kind of unfortunate. The part that sits on my belt is a fairly restrictive, what was originally the Elite Core So all my file names are calling this thing the Elite Core. All the Elite Core is just a converter from XLR to a headphone cable. That's not good enough for the audio though. For the electret microphone, I need proper balancing and stuff like that. So I modified the pack to have mini XLR cables on both ends, because this is what the electret, the lapel microphone had on it originally, and then this is out to my Focusrite, which is providing us with phantom power. The whole reason I'm doing this is I bought a new mixer, and the mixer does not have a good EQ in it, and so I can't replicate the EQ that I use in order to make my audio sound buttery smooth. So anyway, I bought 2 of these Elite Cores. What they are, it's just an aluminum extrusion with a belt loop on it, right? So in order to make sure that I am able to mount the 2 mini XLR connectors and have my full circuit in there with the EQ, I modeled this thing in Fusion 360. So I did a lot of reverse engineering over the weekend. A lot. I spent a lot of quality time with my calipers in order to make the extrusion for the Elite Core. And I've created a 3D model of that thing. Welcome to the chat room. Why is Twitch constantly reconnecting me? Anyway, maybe it doesn't like Chatterino or something. So anyway, I replicated the aluminum extrusions, which was, you know, not an easy task. A lot of lines involved in that thing, right? A lot of lines involved in this thing. And then I went on Switchcraft's website, and they had these beautifully, gorgeously detailed models of the mini XLR connectors. Actually, they were really good, really, really good computer models of these things. And so I added all the materials to them to make them look good. And now I've got a representation of what the circuit board is going into. So this is the first time that I've done this backwards. This is the first time that I've started with an enclosure and worked backwards into having a circuit board that fits into it. I would like to fit this all into here, because I don't want to expand all this stuff. Like, I don't want to wear a different belt loop. I like how cheap and easy the Elite Core is to get. Yeah, I put a lot of work into this to make it, and also to be fair, Zitmus, to be fair, Fusion 360 makes a gorgeous 3D model. You don't have to do a lot of work to make things look really, really good in Fusion 360. It did a lot of the work for me. I mean, I love the look of the outlines and, you know, the shiny materials along with the matte materials and stuff like that. Very easy to do. Yes, I am going to design a PCB and have it fabricated. That is indeed what I'm going to do. That is, I mean, we were talking about that just a second ago when we looked at one of these other projects on this guy's website. This guy's Elliott Sound Project. Elliott Sound Project. It's amazing. The amount of stuff that he does to get near pro gear out of simple, like you know, electronics project kind of stuff. We are looking at Elliott Sound, and I'm looking to combine 2 of his projects to put that equalizer into the electret microphone that I'm using right now, and then fit it into that case. It's going to be a bit of a challenge. It's going to be a bit of a challenge. I need to do that because I bought, like, Mr. Expensive Mixer Rodecaster over here. And the Rodecaster was supposed to balance my audio properly in such a way as to allow me to do things like Zoom calls, which is going to be very relevant soon. Allow me to do Zoom calls with my super duper nice mic setup. Over the weekend, I'm going to have to use virtual audio cables in order to be on Cosmo Quest's show on Sunday, I believe. I'll get more details about that later, but yeah, I'm gonna have to use virtual audio cables, and I'll use OBS as a webcam essentially. So it'll just look like this, but it'll actually be even closer. It'll be even closer. It's actually gonna look like this for me on the show, but it'll be out of focus primarily, and that's how I'll represent myself. Anyway, so yeah, in order to do that, I would have really liked to use that mixer, but I'll get there eventually. I tried Lone Star. I tried using virtual audio cables with Blue Jeans for a doctor's appointment, and it was making intensely crackly audio. And I touched the bit rate, and it ruined my whole setup and stuff. Like, I don't know. Yeah, maybe it's just Blue Jeans. I think Zoom works. I think it works on Zoom. So I think the virtual audio cables work on Zoom. They're very nice, they're very clever, but I would like to get to having like my audio be more of a physical thing where I don't have to be absolutely fucking petrified of touching any of these settings. Think about VB audio cables that there's an in, an out, and a middle bitrate. Yeah, I don't. So I wasn't willing to play with it enough. I'm not willing to play with it enough because if I play with it too much, I could just ruin my entire audio setup, and that scares me. Audio setups are like that. You set them up, you get them working, you get them nice and tuned, and then you never touch them again, or else you'll have a panic attack. At least that's what it is with me. But anyway, this is the circuit that's bringing audio out to you guys, and it's very specific for the Tram TR50. You can put other Electret microphones on this circuit, and it'll sound really good, but most of what sounds really good is this equalizer right here, and that equalizer is tuned very specifically to this microphone. The compressor I can probably do inside of the mixing console, mostly. I don't know if I can give it that nice heel at the end for the cutoff, because it comes in nice and smooth, and it boosts my audio a little bit here, and then it tamps it down for the rest of it. So if I really start yelling, I still sound natural and I don't start clipping. And then if I talk to you guys really softly, if I'm like, hey, chat, guess what? You know, it comes through properly. And that's all tuned to how I talk. It's a very specific setup, which is why I want to tune it specifically to the mic box. And then I can get somebody else in here and I can hand them over a microphone that I've also tuned. And they'll sound just about the same. They'll even have all of my same vocal inflections. Yeah, I would imagine doing a corporate conference setup would be insane. Ugh, scares me. I shudder. I shudder to think. So my thought here is that we split right after that first amplifier, because I'm thinking that first amplifier is responsible for getting the very small voltage Electret signal and boosting it up to output levels, or whatever the common mode audio level is. I don't think putting the EQ ahead of that is a good idea. You need to have an amplifier in there. So if I do that, then I put our stuff right there, and then we pipe it out into everything else. That's my thought. But we're looking at the text in order to see whether or not I'm full of shit. This is the receiving end of the phantom supply, and it powers the microphone and op-amp line driver. Line driver. Line level voltage. Line level voltage. Approximately 1 volt. 0 to 1 volt is what powers audio devices throughout the world. 1 singular volt. And that 1 volt can be converted into decibels. Tell me about mic line level. Anyway, mic line level voltage is 0 to 1 volt, right? So if we're taking it out to 0 to 1 volt, I think that goes into the other amplifier circuit. 110 dB, Jesus Christ. Possibly more. This is more than sufficient for any microphone that's not used in close proximity to loud vocals or instruments. I'm not exactly screaming out here, so... Yeah, 1 volt peak to peak. Keep in mind it's an analog, so it's technically 2 volts if you shift it. I think 1 volt is generally what's used for, like, earbuds, right? And then it's half a volt offset. I forget. Bop, 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 bop. Although U1A is shown with a gain of 2, this can be reduced to unity by removing R8 and shorting R9. I'm gonna write that down. I actually need to save that piece of information because I think that might be the ticket. So remove R8 and short R9. Damn it. Put like a star there. Oh god, this is gonna look terrible. For unity, or no, for remove. For remove, gain 2. For remove, oh god, remove. Drawing letters will really let you learn how and why. We use very succinct language in engineering. Gain of 2. We'll be able to test this, by the way. For remove, gain of 2. So yeah, short that, remove that, and you get a gain of 2 out of this thing. Well, wait. That just goes in like a loop like that? Huh, interesting. Then what's the purpose of this? I guess additional gain? We're using 33K and a 100 micro. All right, maybe that'll get explained later on. So it is a unity gain. Oh, for remove gain of 2. Parenthesis. Unity. Unity, just like the Unity game engine for all of your shovelware needs. All right, you can make a game about scary ghosts and somebody will play it if it's Unity. Anyone will play it if it's Unity. Yes, sir, Unity. It's your way to turn default assets into money. All this will decrease the signal noise ratio and the mic will be a little noisier. Well, we're not having troubles with noise. I guess what he's doing is he's boosting the gain and then he I don't know, what is he doing? A similar but slightly more complex method for deriving the DC from the signal lines is used by Crown on the PC. I don't care. And similar circuits are also used in the other similar. How does it work? It's actually quite simple. Q1 and Q2 are operated as current sinks. Q1 and Q2 are current sinks. What does that even mean? Sink or source. There's extremely high impedance on the collector. There's minimal loading of the signal lines. The DC appearing at the base is filtered by C1. C1 is here. The minimal amount of DC right there filtered out. So that'll act as a short until it charges. Charging through 100K, huh? I mean, I guess, wait, phantom power. So phantom power, I believe it wibbles, right? I don't think Shore is going to really explain it properly. No, they're not. Facebook, really? Not a Wikipedia article in sight? What the ever-loving fuck? What the, like, what? Not even a Wikipedia article, right? That should be, like, up at the top. What are people doing to phantom power? Monetizing stuff on the internet has been the death of decent engineering. Oh my god. Wikipedia. Phantom power. Blah, blah, blah. They use it to do stuff. Here's a bunch of Zener diodes. I want to know what phantom power looks like. Is it like AC? Digital phantom power. Oh, God. Choice of internal power. Phantom's not already implemented correctly. Blah, 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 blah. Phantom power supply invisible balance microphones that don't use it, which includes most dynamic microphones. A balanced signal consists of difference in voltage between two signal lines. Phantom powering places the same DC voltage on both signal lines of a balanced connection. Okay, this is in marked contrast to another power supply earlier method known as parallel powering, or T-power, from the German Tonaderspielzung. Tonaderspielzung. You need T-power in order to say that word into a microphone. I'm gonna start, all the IKEA furniture is gonna start floating if I keep saying that. In which DC was overlaid directly onto the signal differential mode, connecting a conventional microphone to an input that had parallel powering enabled could very well damage the microphone. Yeah, it could also damage the artist. There have been a lot of electrocutions with microphones in the past. IC, bobbity-ba, 48 volt, 24 volt, 12 volt phantom powering, signal positive. Both fed through resistors of equal value. The shield ground, the 6.81 is not critical, blah, 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 blah. The 24 volt version of phantom power proposed quite a few years after the 12 and 48. Okay, I don't know. So, what is it doing? It's putting power on both of those signal lines so that it is a common mode noise. So they're using the common mode noise filtering method of the differential signal line. They're relying on that in order to provide 48 volts out to your device. And so this thing is taking in that 48 volts, and it is doing some kind of a mystery weirdness to it, possibly voltage regulation method, in order to pull that shit down to where it needs to be at 14 volts positive here. And so we've got 33K going up to 14 volts. We've got 100 microfarads going down to ground, which is pin 1, which is that's all fine. We got 100K coming up to the electret, and we got 100K going down. That goes into the positive. What the fuck is... Okay, I'm still trying to figure out what this circuit is doing. And his suggestion is that you could also remove this reference, and you could make this a line, and then the gain on your circuit is going to be unity gain. So gain of 1. Back to the fun text. Fun, fun, fun. It's actually quite simple. Q1 and Q2 are operated as current sinks, and their load is connected to the emitters. Because the current sink or source has extremely high impedance on the collector, there's minimal loading of the signal lines. The DC appearing at the bases is filtered by C1. What the fuck? Okay, hold on. So those are connected with a 100K. They're connected to each other. They're connected to one of the differential lines. This one's connected to the other one. And they both got the 470 and the 10U. The 10U is there to get rid of any DC that's on the line. Does it waver between the two? I don't know. I guess we're filtering out the audio from our line. Collectors only see the DC. The AC signal is left untouched, except at extremely low frequencies. Okay, all right, so that's what we're doing. So there's audio on these lines, which doesn't help our power supply. And if our power supply is wibbling around with the audio coming out of it, then we're going to get wibbly power, and we don't want to wibble our power. I'm going to keep saying wibble until it loses all of its meaning. Semantic satiation. Anyway, so what's going on is my vocals are fucking gallivanting all over our wonderful power signal. And so we want to get my voice out of the power signal, much in the same way I was kicked out of Kroger's the other day. So while that voice is wibbling around and talking bullshit about vaccines causing DNA shedding and shit like that, what we do is we put a mask over it so that it shuts the fuck up. And so that's what this circuit is doing. As the AC comes in, these two guys right here are going to start varying the amount that they're allowing, varying the amount of voltage that they're allowing to come through here and power the rest of the circuit. So the louder it gets or the lower it gets, it'll balance it out. It'll try to balance it out. That's what's going on over here. This is important. This is our final stage filter for getting rid of my fucking voice. So that our power supply doesn't have feedback on it. Because if that power supply has feedback on it, it's going to affect the whole circuit. I mean, like 14 volts wibbling about 1 volt would be kind of bad. Yeah, voice is wibbling power. We got it. We got it. We got there. We got there. This says nothing for the rest of the circuit, but I finally understand what this shit is doing. On a 500K voltage divider? Yeah, I'm kind of thinking that too. But, I mean, that's what we got. I mean, we got 1 volt here, and then this thing is getting rid of that DC. It does an effective job because you're listening to my voice right now, so, you know. What is the division on that? 100 to 470, and we've got 48 volt phantom power coming in? I'm just going to do a voltage divider. I'm too lazy. This is, by the way, this is how you learn stuff. I hate to tell you, chat, but you guys are actually, like, almost not here today. This is how you learn things, by teaching it to somebody else. If you can teach something to somebody else, you get the benefit of having, like, you get the benefit of having the goal there that's going to drive you to do it. And then you also have all the little details that you didn't flesh out come up and hit you in the face. Go, oh, why do we use that number? I don't know. Like, so you guys are helping me out with that right now. All right, so voltage divider calculator. I don't care about this though. Well, let's put in like 48 volts, and our resistance 1 in ohms is 100,000. Oops. 100, 0, 0, 0. And then our resistance 2 is, what was it, 48? Oops, that's not it. Paint. 470,000. I don't want to use the pull downs because it's a bad habit to not work in ohms when you're dealing with Ks. Yeah, it's a form of rubber ducking, yeah. I mean, 48 down to 39. It'll see that volt. It's not a lot, though. 40, 41, 42, 43, 44, 44. We're like 8 volts down. Not exactly having the voltage, is it? Not exactly having the voltage. I don't know where the BC549 bias is, but yeah, this is something like 38 volts here. How does it then turn that into 14? Am I misreading? 100K, 400K. For 100, 470, rather. Man, I don't know. The circuit works. The circuit works, so... I mean, this is 48 volt phantom power, I think. Are the op amps just, like, capable of operating within that voltage? Am I, like, throwing, like, billions of volts at this fucking thing? I don't even know, man. I don't even know, man. DC appearing at the bases is filtered by C1, so the collectors only see the DC. The AC signal is left untouched except at extremely low frequencies. R14 is described as SOT, or select on test. This resistor needs to be chosen so that the DC is about 10 volts with a normal phantom supply of 48. I did not do that selection. Oh, R4, oh. Wait a minute, R14 is on the base, though. Yeah, I guess that's what does it, right? Because we would be adding it to the voltage divider. Well, but that's on the base. We're adding it here. We don't have, like, a... I guess we've got... That's through there. I mean, that's directly, and then there's R14, which is pulling down. So I guess these are, like, eating a lot of the excess current. Oh, my God. How are they not on fire? I don't know. C2 is then snubbing it out. A Zener may be used instead, which will give a little bit more of a voltage range depending on the op amp used. Interesting. So, I mean, this works with the op amps that I chose. I didn't find these. I didn't buy these. I bought different ones. I think they just wiggled high voltage by a small amount. Huh. Yeah, 100, 470 is on the base. Yep. It's still like 38 volts to put on the base, though. It's a lot. I don't know. The minutia. I don't know the minutia of how this thing works, right? Your output's whatever causes to flow across R14. I forget what I did with R14. I don't remember what I did. Yeah, I don't remember what I did with R14. I don't know. It's not going to be R14 on this, but it'll be... Oh God, I don't know what all the values are on the circuit that I made. I'm going to have to rebuild this thing. Because we need one for testing. I don't think they have the same values as in the main circuit. No, I think I just left it up to myself to figure it out. There is a diode, though. So maybe I did put a Zener diode in there. That goes around. So R5, yeah. This is the circuit that actually drives the audio that you're listening to right now. I did not build a second one, and I probably should have at the time, because I'm going to have to get into this and figure out what's going where. I'm not gonna have to fully reverse engineer it because we literally have the schematic sitting in front of us. So I'm just gonna have to figure out what specific trace I'm gonna have to cut in order to produce the appropriate test bed for the rest of our circuit. Oh boy, we got work to do on this project. Shit. I'll have to get parts and stuff together, maybe on Wednesday, but on Wednesday I promised Julian that I'd look at his project. So I'm gonna look at Julian's project on Wednesday, and we'll try to get him in on the show soon. R3 is used to ensure that there's some voltage across the transistors. That is this guy. So R3 ensures that there's some voltage across the transistors. Differential must be greater than the expected peak output. As shown, the differential is about 3 volts. So a 6 volt peak-to-peak signal can be accommodated. This is equivalent to an output level from a microphone of almost plus 10 dBm. So that's like, yeah, 6 volts. That's a lot of volts there. Let me note that down. I probably have old notes that say that. 6 volt. R3 is used to ensure there's some voltage across the transistors. The differential must be greater than the peak output. As shown, the differential is about 3 volts. So 6 volt peak to peak. P2P. Output level is about the same as the discrete version. It's more complex. The board cannot be made small enough to fit inside a slim microphone housing without resorting? What do you mean resorting to surface mount devices? Surface mount devices are awesome. What are you talking about, Elliot? Most common variant, simple DC extraction circuit uses a transistor as a capacitance multiplier instead of just a capacitor. This has not been found to be necessary practice. The schematic shown found that it works without all the extra complications. My prototype preamp uses an OPA 2134, relatively high current op amp. It's a working voltage of a little over 10 volts with 48 6.8K phantom feed. I should note. Tune to 10 volt or Zener. And I may have gone with the Zener. The output level capability is extremely high. 2 RMS can be achieved with quite easily by speaking directly into the mic loudly. In all capable preamps, blah, 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 noise will become an issue. All right. So, I don't understand where I got the dumb idea to put a Zener diode into this thing. I don't know where that circuit came from. Somewhere I got it in my pretty little head that I was capable of doing things like this. This is a variant on it. There it is, D1, 10 volt. But that goes between power and ground. So it'd actually be... Is that in here? No. Because it showed it like here. That was 10K, 100K, 100K. That goes out to 100K in a capacitor. And what he's done is he's taken that and he's spread it out to both of the op amps positives. He pretty much puts it right in here. That transistor's going between, oh dear God, I can't interpret the rest of that. Let's just do a Zener diode here. Make it do the little wiggly arms. 10 volt. That doesn't look right. Close enough. I'm wondering if in the project directory I have some kind of a record of this. Hold on, let's see if it's in my project directory. That would help me out a little bit. Stream, and then, oh God, what would I have called it? Lav mic? JKL, yeah, lav amp. It's literally just a thing about balanced interfaces. Damn it. This is my initial research. I until I found the Elliott Sound project. Maybe I like modified it with some stuff from here. I don't think so. Hold on. Looking through. Oh my god. No, this is just me learning about. Yeah, this is a long read. This is a hell of a thing to read about, though. That wasn't it, though. That's the only information in the project folder. Centers for the optional 9-volt input. You have that optional input on your circuit. Is it? Oh, to use the preamp on battery power, leave out R10 and 11 and connect a battery to VE. Must reverse your plan on using battery power. D1 should also be omitted. C5 and C6 must be reversed if you plan on using battery power, and D1 should be omitted. Omitted. Current drain is quite low with 5 LMS and 9 batteries last quite well. The mic must never be connected to phantom power if it's adapted for battery usage. The C5 and C6 would be reverse bias. C5 and C6 are these two. So I have those two here as C6 and C7, and then I've also got the diode up here. Chat on screen, yeah. I thought I would spray for toxicity a little bit around here. It's good to have chat there because I interact with you guys a lot, and it's good to see what people are saying. If I ever actually upload stuff to a VOD channel, I should just start uploading stuff and just not look back. It's like 2, 3, 4 years of streaming that would just be like gone. I have a hard drive sitting in the corner, and then I got the archive drive over here, and I could just, yeah, anyway. What's been my favorite project so far, asks Sick Bastard. Man, that's a tough question, man. It's like asking favorite kid. A lot of projects have been very dedicated. I think I like the way the computer project turned out. I think I really like how that turned out. I don't get to show it off very much. My carbon fiber plate, hex mesh, custom power supply that got upgraded into Noctua fans. Unfortunately, I haven't gone to many LAN parties, seeing as the fucking apocalypse happened, so... I like that I can put it on a big TV now and still see chat when I want to chat. I can open chat. Chat. Yeah, that's, hey, man. It's, I don't know, it adds a little bit to this mostly static camera. All right, so I think having worked it out, we're basically like modifying this, adding D1 over there in order to make it the voltage that we wanted to make it, instead of fiddling around with R14. I'm not entirely sure if I've even implemented R14 into the final circuit. Maybe I could find my old Eagle files and see if I can import it. Because I really do want to replicate the sound that we're hearing right now. But we do know this. We do know that we have a gain of about 10 dBm on this thing, and that is achieved through the second amplifier. From what I understand, my theory is correct. About here, we've got a 2-volt. I think RMS, I'm not sure. Did you say RMS or did you say peak to peak? Yeah, 2-volt RMS. I think that's, he said there, right? Output level capability is extremely high. Oh, that's the level capability. Hold on, wait a minute. Wait a minute. 6-volt peak to peak. As shown, the differential is about 3 volts, so 6 volt. That's coming out of the thing. Where does he talk about shorting? Getting enough current from the non-trivial task, 6.8K feed resistor short to ground. The maximum available current is 14 milliamp. That's not true. But with no voltage at all, for workable current of 10 milliamps, maximum available power supply voltage 14 DC. Getting current as low as possible is a fine goal, but all the op amps need some current to operate. This is the receiving end of the phantom power supply microphone amp. Sorry, I'm just speed reading this. 110 dB, possibly more, sufficient. U1 is shown with a gain of 2. It can be reduced to unity by removing R8 and shorting R9. So that's not 2 volt RMS. That's gain of 2. I don't know what that means, though. If that's got a gain of 2, what are we pumping out of this microphone? What is the voltage level of an Electret microphone? He probably explained it up here somewhere, but I can't be asked to read that. Directly using 9 volt, that's that one. The original mic, housed in plastic case, picked up a lot of, used 1.5 volt cell. It might be 1.5 volts, right? Second objective will increase the cell 5 volts to 1 volt is a supply of 5 volt or more is recommended. This in turn solves the next 2 problems as well, since more signal from the mic. The noise contribution is lower. Let's see, output impedance, 100 dBl. I don't think it's 5 volts, though. I mean, it's 10 volts, right? 5 to 10 volts, never seen a failure. The lone advantage remains. We can't change that, blah, blah, blah. Oh, boy. All right. Yeah, sorry, I'm just looking through this to try to get all the information. I'm trying to get all the information so that I know what I'm going to actually commit to here, because what we want to do is in this part of the circuit right here, I need to actually insert an equalizer so that we can have it constantly on my microphone. And that would be this circuit here. So assuming that we are getting a proper signal, what would be similar to whatever's coming out of the other parts of the circuit, right? Whatever's coming out of here through whatever amplification. So he's got a unity gain amplifier as a buffer, and then he's throwing it through a 3.3K out at this stuff. And then this thing is taking the frequencies and adding or subtracting to them, going through there and out. You do believe the others say that if you unplug phantom-powered mics without turning off the power first and draining the power, you'll damage the microphones. I don't think that's true. I mean, I plug and unplug this thing all the time, and I don't think my microphone's becoming more damaged. I've been doing it for like 4 years. I don't know when this was originally sent to me, but yeah, this thing's been unplugged hot throughout its entire lifespan. Although my circuit might help in that. I don't know. This isn't just like a transformer that we're putting everything into like you would with a typical, they sell little transformer packs that you can put in line. So, you know, it's possible that my microphone or my setup is actually protecting it when I accidentally unplug. That's a possibility. Yeah, maybe we just gotta do this. Maybe we just gotta put it together, right? What's he doing in his preamp? Oh my god. He's got like overload. He's got the 1N4148s as his overload senses. So like when the 1N4148 is overcome from the voltage, it'll trigger an LED that's sent, they're basically, overload is sent out to everything. Everything has that 1N4148 on its stage, and when the voltage level present overcomes the diode, it's able to power an LED that you see as an indicator, which is kind of fun. These are graphic because they're in parallel. Signal comes in, goes 3 ways. The original signal here, bass, treble, mix again, feedback, and amplification. Interesting. How does that not feed back into itself a lot? I guess it does. That's weird. Okay, anywho. Yeah, we're gonna have to build some of these. So I gotta find parts. Or we do the graphic equalizer, and then with the graphic equalizer, Graphic equalizer, which is where? Oh boy, I got so many windows open. Curse you, Elliott Sound. With a graphic equalizer, we have everything going into just a big bank. That doesn't use op amps, although there is a version of it that does. And I can't find the page with the op amps on it. There's a version of this that uses op amps, and you would do them on a big bus. Because what goes on is that everybody sees that full audio signal, and they only concentrate on a certain percentage, like a certain part of that signal, and then you just put it through a potentiometer on the output. And that can make you somewhat of a wavy output if you try to put everything to the same level, but flat frequency response is not our goal here. In fact, if you just look at what I do, it resembles that wibbly wavy line. So maybe we can get away with 6 parallel structures, and then I don't need to get dual potentiometers, which I'm finding it's hard to find them. Hard to find dual pots that do what I want it to do. And the 10K pots that are those scientific instrument ones are what I would like to use, and then I could put 6 of them into the circuit. That's still very large for the amount of space that we have to deal with here. We're in a very limited amount of space. What do you guys think? So should we do panometric, or should we do graphic? Graphic versus panometric, parallel versus series. These are the debates of our time. There's a Windows update to install again. What the fuck is Windows doing? Getting real sick of Windows updating all the time. Where are my 0-day exploits? Low mid, high mid. Yeah, what are the pros and cons? The parts that I need would be the main pro and con that I'm coming up with right now. Because I need a dual potentiometer of 100K for each of the 6 bands. So I need 6 dual potentiometers, and then I would need 6 regular old 10K potentiometers for all of them. I turned off TPM in the BIOS to prevent the free upgrade to Win 11 from getting forced. Is that really going to get forced? Why do you have a tire pressure monitor in your thing? So the con of the panometric is that everything is in series, right? So your sound has to go through 6 devices before it comes out. That could introduce noise potentially if I use. Oh yeah, thank you guys for the follows, by the way. They forced Win 10 on a bunch of people. I don't doubt they'll try it with 11. Somebody will come up with a disable for that. Inevitably, it'll happen. They always do. So yeah, the disadvantage for wibble down the lane or panometric is that my audio signal goes through sort of a whisper down the lane, amplify or lower the amount of sound for all of the 6 channels. The advantage, I'm not sure. The advantage, I guess, is that the entire audio signal is being worked on. So all of the information is there. Whereas with graphic, what I'm doing is I am taking an individual section of that audio, that full audio that comes in, and I am only listening to that section, and then I'm either amplifying it or lowering the volume of it, which I think this would get me to where I am. Now, he said it was a fixed Q. Q is like, I think, the width, the bandwidth that this thing looks at. If you go too wide in the Q, as in your bandwidth, the amount of the signal that your amp is listening to, if it listens to too much of the signal, there's overlap. And so that overlap could cause issue. Now, in my setup, there really isn't that much overlap. And I don't know if I need a specific amplifier to do. I don't need an amplifier to do the cut, right? I shouldn't need an amplifier to do that cut. I don't know how I do that cut. I might not be able to do the cut. The cut is just there because I'm not broadcasting those frequencies. I mean, I don't think I'm a squeaker. Look at where my voice is, right? Look where my hand was. Letting the days go by. What I'm doing is I got a little bump right there. That's the important little bump. Then there's a shelf, and then we drop out on some of the slightly higher frequencies that I'm producing. And then that's sort of, I don't know, there's a little bit of an amplification of the high frequencies. Like if I do this, I don't know. How clean will the signal be at the end of the line, or does it not matter? Since it's turned digital at the PC. See, I don't know. That's the problem. When we when we breadboard this circuit, we will be introducing a lot of potential for there to be noise in the line, depending on the parts that I use and how they fit into the perforated prototyping, or so the breadboard. I keep mixing them up. Why do I do that? Anyway, depending on how they fit, how all these parts fit into the breadboard, there might be a little bit of, you know, gonads and strife on the other end. But I think we should get a pretty clean signal no matter what, as long as I'm using low noise op amps. I don't know. I mean, we'll just have to see. Yeah, I guess I'm gonna commit to trying to one and then see what it's like, and if I can replicate how this sounds with a pass through or something like that, then we'll move on with it. Otherwise, I'm gonna have to take a look at like the other circuit and see if that one does what I want it to do. Or maybe I need to look at some of the guitar amp, or the bass guitar amp thing where he does both. But you know, like just a bass treble mid equalizer is not going to work for me because it's voice. I need to make sure that this comes through, or else my audio sounds like absolute crap. Then I got to figure out the compressor too. I don't know how to get that. This is not a good idea. Oh no, he's got one in there. Simple bass guitar compressor. Bass guitar amp. Oh boy. Tell me this is an easy circuit. It doesn't look like an easy circuit. 12 volt grain of wheat lamp. What? What the fuck? Okay, hold on. Clear perspex rod, grain of wheat lamp. What the hell is that? Unplug with phantom power only happens with TRS plugs. Oh, okay. Yeah. So if you're doing phantom power into a tip-ring shield like your typical headphone plug, then you can run into trouble because those contacts will rake across. It's an optical compressor. Yeah. What? That's crazy. Yeah, somewhere in here there's a compressor. That's just compression. I don't think I'm going to be able to get my digital super duper compression. That's a wild thing. So they're just putting it up to light. Control F, compressor, who also incidentally does not dance. Okay, there are... Oh, it spelled it wrong. 10 mentions. There we go. LED compressor. An LDR is a light-dependent resistor. They're typically very slow in response. I'm surprised that you can get away with that. You're gonna build this whole project? Damn, dude. That should be fun. Give yourself plenty of space. Because I'm gonna run into space issues. So he's got, from the FX return, he's putting it through a stage of amplification, fixed amplification. He then has a variable gain of compression that you can implement. Reference to ground. The output of that goes through a light-dependent resistor and fires it up and down. So the more gain you give this, the more this is going to clip it. Because it can only... Wait, but that's an LDR. Why is the LED on the opposite side? What the fuck? Wait. What? Well, I guess it's coming out of here. So this is working as the brighter it gets, the more resistance there is, the higher the gain. And then we're relying on this LED to feed it back. The 1N4148s, are those overload, or are they... They're doing something over here. And then we're outputting to our volume out. And then there's a distortion control over here through LEDs. Oh my god. Wow, okay, weird. That's crazy. That's some crazy stuff going on with it. I didn't know you could do like an optical coupler in order to create. Well, it's an optocoupler using an LDR, which is not typical because we're not doing digital signals. We're just doing analog signals, and so you have a lamp, and the LED can only get so bright, right? If you get that LED to be just at the right voltage bias, you'll get dimming and stuff with it, which is what's transmitting over those, I guess, the audio. But it can only get so bright, I suppose, and that's how the brightness of that LED is then being fed back into the system. That's why this is wild. This is some weird stuff to me. Analog stuff is so cool. Can't believe you can do all this with just some simple stuff. But again, that's not gonna achieve. That is not going to achieve this. Oops, that's not gonna achieve this. This. I don't know what could achieve that. I'd have to do some research on that. Plus, I think the Rodecaster will do that. Ooh, my stomach is a war zone right now. I don't know what's going on with that. It decided that it did not enjoy ham, I guess. Peak limiter. Oh, I see. So it's just a peak limiter. Cheated by simplifying the circuit. The ascent shown. I've tested the compressor limited with off-air program material from FM radio, bass guitar, ordinary guitar, and tone burst signals. There's no evidence of distortion. Mainly thanks to the 5532, which can provide a far higher output current than most common amps. Interesting. Yeah, it's pretty crazy. I'm like, there's like lava down there. When you get like a little half burp, and you can kind of tell how much it's going to hurt. The optocoupler can be a proper Vactrol VTL54C, or you can do it yourself. Oh my God, look at that thing. That is ancient. That's crazy. All right, well that solves. You know, I think I've seen devices that have one of those in it. Maybe not that same product, but like this weird component with 4 leads coming out of it that I wasn't able to identify. I should have known at the time. Old equipment. Crazy stuff. Anyway, before I get to just reading everything, we're gonna have to figure out where I'm gonna get the parts for these. I think the main reason that I would go towards the graphic equalizer as opposed to the Panameric one is that the graphic equalizer requires 1 potentiometer to adjust, and I could do it with I think there's a version of it that uses op amps, but I mean I could just use transistors to do it, and we can see what happens. If I'm doing transistors and I have 1 potentiometer per band, that's going to very easily seat me in a place where I can put this all onto a surface mount board and make it tiny. I don't know why it's called graphic. I don't actually know that. Oh, because of the graph, I guess. Because it comes out in bands, and then it's like a graph. I don't know what panametric means. You have a command. Do like the mic command. And then it's just literally Project 149. Tone control response are taken for 2 pots, 0% maximally cut, 20, 50, 50, 75 maximum boost. Combined with the extraordinary flexibility of the graphic equalizer, the range is truly vast. No graphs or charts can ever tell you what something will sound like, but it should be obvious there are a few limitations with the combined circuits. That's kind of what I'm looking at here, yeah. That's kind of what I'm looking at. There's, so I guess we're just going to have to test it, you know? Word of warning, don't expect this preamp to be especially quiet because it won't be. Use of low noise op amp on the input stage mixer helps. With all guitar preamps, some noise is inevitable. This is made worse by the filter circuits. Each only adds noise on its own band, so the cumulative noise is not as great as it otherwise might be. Using the distortion control or treble boost will increase noise. This can be dramatic at full gain. In reality, it's not much different from a conventional guitar preamp, but it's turned up loud. You get the same distortion. The more gain you have, the greater the noise. I'm not using a lot of gain, even in terms of his, like, I was looking at, oh God, the ARG continues, and the number of tabs that I have expands exponentially. Guitar amplifiers are always an interesting challenge. This is the original Project 27B guitar amp. It's unusual to use a back-sandal feedback tone circuits in a guitar preamp, but they're more useful here than a more traditional tone stack. So this is a more traditional tone stack. Warning to all guitarists. Never do so anywhere near an amplifier or close to a mains outlet because the strings are thin. The top E string in particular, they can easily work their way into mains outlets, ventilation slots, and all manner of tiny crevices. Oh my God. The springiness of the strings means they are not easily controlled until firmly attached at both ends. This is very real. Here's a picture of an Australian mains plug that was shorted with the guitar string. Oh my God. The knobs resemble a graph of the equalizer response plotted versus frequency. Yeah, so all those bands that you're putting together, they're usually a bunch of slider potentiometers in a row, and so that looks like a chart. Yeah. The LDR being slow might be the point, as the slowness would smooth out the signal, averaging it, and thus adjusting the gain according to overall volume. I was thinking that too, yeah, I think you might be right about that. So this is a 100-watt amplifier. With a nice blurry photo. Dear God, this is what we opened this up before, but oh my God. Mid, bass, treble. Literally just all stacked on top. It's just like a capacitor filter. Wow, okay. Is that phantom power right there? There's a link, little whoop. How is he getting all the freak? I guess it is just the capacitor. He's just filtering it through the capacitor. So that's a tone stack, I guess. Did he improve anything down here? There's a new version of this. Look, I'm not. You guys are gonna bury me in stuff right now. So I'm literally just paging through this right now because I just wanted to get that reference there. So back-sandal feedback tone circuit. What does that even mean? Back-sandal. Circuit discussed here is an example of back-sandal control circuit illustrated in figure 422, which is an analog circuit providing independent control of bass, treble, and frequencies. Both bass and treble can be boosted or cut with both controls in their mid positions. Provides a relatively flat frequency response. As illustrated by the blue level response graph line in figure... original design proposed by P.J. Baxandall. James Baxter... in 1952, used a valve amplifier and feedback as part of the circuit to reduce considerable attenuation introduced by the passive network and to provide the bass true treble boost and blah, 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 blah. Damn. Okay. All right. I don't fucking know. What is this? Treble. Where's the bass? It's over here. So there's back and forth. You get your input in there. You get one that goes through a 10K, then a 2N2. Bias to ground. Jesus Christ. I don't understand any of this fucking shit. I don't know any of this stuff. Oh, dear God. Yeah, this is what I was talking about. This is what I was looking for. A tone control integrated circuit. So instead of doing all this stuff with discrete components, I can plop one of these fuckers in there and just get it all to work. I have volume, I've had treble, I'd had bass. I wonder what kind of stuff like this actually exists. LM1036 from National Instruments, huh? The problem with these chips is that they tend to be very, very big. We used to use a lot of audio control stuff in the brain monitoring probe because they were sending back analog signals from from optical amplifiers, and a lot of audio control devices were used in order to make. It was like before digital potentiometers were really a big thing. So they used audio devices in order to do some amplification, low noise amp stuff. And so I've had experience with these chips. They take in like 15 volts, and they require a lot of other stuff around them, and they're big. They're big chips. I'm sure they're smaller nowadays, though. Block diagram application circuit. Each of the 4 controls adjusts by applying a variable voltage between 5 volts and 0. Half of the voltage applied to the control pins gives level frequency response, general balance. The LM blah blah blah. Provision for loudness compensation switch. Well, it's cooler to use discrete components, right? Yeah, we gotta find the next click in our ARG that'll get me to the circuit that I want to... do they call it an ARG just because that's the noise you make when you have to go through all this shit in order to get what you want out of it? It's like the most useful thing I've gotten so far is this graph. I am of a mind that first we should try the one that needs less stuff. We should try the one that needs less stuff. So I'm going to get my ducks in a row for that one. I don't think I have the potentiometers that I want. I need a bunch of these 100K jobbies, and these are all 50. Let me check here real quick. These have the value written on them, so let me just check some of these values. Getting real stuffy in here. We've had wonderful fall weather, though. I'm super excited about that. So does 503 mean 50K? I mean, these are in kind of bad shape, but let's just see if 503 means 50K. And then, I don't know if we'll do it on Thursday, because on Thursday I really should be working on Burn the Subs. Unless I move Burn the Subs to Friday and we work on this on Thursday. Because if we do work on this on Thursday, that means that we'll get down to the more cool physical stuff. Yeah, I'm just verifying that it does. So across the 2 ends of the potentiometer. Yeah, okay, so they're 50K. So these are all 50K. Or at least this one is. Let's see what the others are. Let's find out. Uh, 250K. 254. They're doing a thing like on resistors where they give you the first 2 numbers are basically the value, and then the third number is the number of zeros. So 503 is 50K. 50,000. This one literally just has the value written on it. It's 150K. So we want to go out of range a little bit with this. Or is that 100? I don't know. I feel like we probably need to build the whole circuit in order to test the whole circuit, huh? That's 100K. So we have 1. I think I'm gonna just have to order a bunch of these, which means we can't do this tomorrow. I don't have a place where I can buy specialty stuff like this so easily. That's another 50K. Only this thing used 50Ks. 5K. What are you even doing here? I just bent the pins by accident. Oh wait, no I didn't. I guess you can't. Oh, it's got min and max on it. What does it go to? Does it go to 11? It goes to 8. What the hell kind of a volume knob only goes to 8? Ugh. No, there's 502. 502, so only 2 zeros on the end of this. This is 5Ks. Ah. Yeah, no, it should go to 11. Well, I mean, I guess they're counting up by 2s. But that would make max 10. And then when you get to 11, 11's here in between min and max. Is bullshit. So I need to order a bunch of these because I don't have the values unless I do 250Ks in a row, but I'm not going to nearly have enough parts in order to put this thing together. especially with all 6 bands. We want to put our best foot forward. What we can do tomorrow, sorry, not tomorrow, what we can do on Thursday, what we can do on Thursday is we can figure out the meaning of life. No, what we can do on Thursday is figure out putting together the audio circuit. 2 of these things are not going to perform the same way as one another, but we can put together a little bit of the audio circuit. You know, we can do a little bit of soldering on that, put that together, and start setting up our test bed for the rest of this thing. Because I'll have 2 pretty extensive circuits to test with all this stuff. You guys are kind of in the way right there, aren't you? I guess it's okay. If I sit a little bit more, if we are not doing a computer day, I'm a little bit better framed for this. What are you building? Oh, it's going to take me so long to explain. So the lavalier microphone, lavalier, the lapel microphone that I use, actually, yeah, lavalier, lav mic. The lapel lavalier L-word mic that I use has wonderful sound and wonderful frequency response, and we can hear everything that's going on in the lab. The problem is when I plug it into my new mixer, I can't give it an EQ that sounds like this. So what I'm trying to do is I'm trying to implement this, and I'm using the Elliott Sound Project's website. If you're into electronics, you're inevitably going to do a project that involves sound. And the Elliott Sound website has a lot of good stuff in it. What we're going to try first is a graphic equalizer, which takes audio in, splits it out into all of its frequencies. Well, basically buses the same audio signal into a bunch of amplifiers that are only paying attention to a specific frequency. And so if you try to get a flat response out of that, your flat response is going to look a little wibbly, right? But then you edit those bands in order to create what you need on the output. So it's almost, you could almost overlay this on top of itself in order to figure out what exactly I'm trying to do with this. Now these, I am going up to 6 dB. So I think this will be capable of that. Yeah, that'll be good. I'm not really even going close to 6 dB, actually. Yeah, I'm like, I want it to be like down here. So yeah, I think we'll be able to do something pretty good. The raw edge plank looks pretty good in the background. Thanks, man. Yeah, Thursday I do want to get some stuff done on Burn the Subs. I've got a part coming in the mail today, and so I'll be able to start 3D modeling I want to 3D print the hot end. I want it to be nice and clean this time. We did clean up a lot on the hot end, but there's some like dimensions that I'm not too happy about. That was a lot of information for my brain. Yeah, how do you think we feel, man? We had to figure out whether or not we wanted graphic or if we wanted panometric. Panometric equalizer puts a bunch of blocks that look something like this together, and it's a lot of op amps, but it might give me a better response. It might give me better sound. Although that means that it's like a series event instead of parallel. So we gotta put these to the test, basically. Yeah, an analog EQ. I will not be adding a compressor because I don't think I can get the same compressor response out of... what I basically need is a whole fucking digital audio workstation, which is why we have 3 options here. We have 3 options. Graphic, panometric, or I just go to an FPGA. If I go to an FPGA, that means that what I'll be doing is taking the sound and turning it digital. So you turn it into what's called I2S, which is Integrated Circuit Sound. I2S. It goes into I2S. It all gets farted into an FPGA digitally. The FPGA does something with magic that will then be able to put it through a very advanced set of filters that could potentially do this work for me if I do enough reading and studying about it. And then I could get this sound directly out. And since phantom power is 14 volts, I could turn that into FPGA power pretty easily. It's just, I'm not good with that. Like, I haven't done a lot of stuff with FPGAs. I haven't done a ton of stuff with FPGAs. So I don't really know what I'm doing. I'd have to learn how to do it. I don't want to learn how to do it yet. So that's why we're going to try analog. So either 2 options for tomorrow, Thursday. 2 options for Thursday is either building the graphic equalizer a little bit and building up our test circuit so that it's got all the stuff that we need on it, our test setup, or I could work on Burn the Subs, and we could do more graphic work. Hey, iMac Farlane just subbed. Hey, thank you very much. Yeah, iMac, what's going to happen now is a series of events that'll lead to your demise. No, what's going to happen now is that we're basically your name goes on a list, and when we finish Burn the Subs, which is the thing that I've neglected all day today, Burn the Subs really lets me like get up and move around. I've noticed it helps keep me from getting fucking blood clots in my leg and dying. Your name is going to go on a list, and then the initial names that are burnt with a laser onto that board are going to be randomized, and basically everybody that's subbed in between boards is going to end up on this one. I don't know how big the backlog queue is. I'm afraid of it, actually. I'll have to address it at some point. I'll have to make that list. I'll get rid of repeats on the list, too. Doesn't need an FPGA, just a fast processor and a codec. Teensy and Teensy audio board would do all this. There's a Teensy for audio? That's cool. Great for prototyping EQs and compressor, leave new sound processing and synths. Oh, that's kind of cool. I should look into that. Initial O, hey, thank you for the 4 months. I appreciate that. Well, you're going to go on that list too. Teensy soundboard? I mean, I really wanted to do the FPGA because I wanted to make a voice changer at some point. Dear God. I2S quad. Oh, dear God. Amp, mixer, synth stuff, effects, multiply, rectify, delay, bit crusher, mid-slide, granular, combine and waveform, biquad filter. Oh, dear God. Here we are again. I'm actually looking at the stuff that can go into the Teensy audio system design. You can just throw a biquad in there. That's dangerous. Yeah, the Teensy seems to do voice changing too. I'm just looking at it, man. Hey, Baloo. This is pretty crazy. And then you can control external devices. Yeah, this is pretty wild. This is just me looking. Sorry, what you guys didn't see was me opening. Oops, Control-Shift-T. Back. Can you take me back a little bit there? I just Googled Teensy sound, and I got this Teensy audio library. All audio CD quality. So there's an audio system design tool. So you can take I2S in, which I have all the stuff for this, by the way. Mahalo, thank you for the gift. That ended up with Radnif. Hell yeah. Thank you for gifting Radnif a sub. I really appreciate that. Really great. Use it loads. Okay. Yeah, I still kind of want to do this with the analog stuff, though. Do all the hype things. That's right. Yeah, it's pretty wild. I have plenty of Teensies sitting around, too. Radnif. Gets a sub. Thanks to Mahalo. Mahalo, thank you so much. Keeper of Maps, thanks for the 100 bits. Everybody's doing hype train stuff now. That needs to be a little taller, doesn't it? Hold on, which one are we looking at? We're looking at Streamlabs. I hate how you can't, like, necessarily click on, even though it's up in front. I'm gonna lock down my face cam and then try to move. It doesn't let me. Like, OBS is so weird with the layering. What's up, Groovy? I can't click on my Streamlabs thing anymore because it's like it thinks it's behind stuff. Like, hey, can we please put this up front so that I can click on it and move it? Nope. Nope, it won't let me. Isn't that fun? Ugh, okay, anyway, I'm gonna move on. So yeah, okay, so I could do a lot of this stuff with CD quality audio with the Teensy, which is very interesting to me because then I could just plug in, I could just throw a Teensy in here and power it off of Phantom. And then I could do the filtering that I need to. I probably, from what it looks like, I need to do a biquad filter though. And that's scary. Man, I could have made a whole audio solution out of this thing, huh? Fade, chorus, flange, reverb, freebird, delay. Yay. That would be a good one for the one thing that I wanted to do. Biquad, FIR, finite impulse response, huh? Regular old filter with 12 dB octave roll-off, adjustable resonance, optional signal control, corner frequencies, or a ladder. Low-pass filter with a resonant feedback means approximate the classical Moog sound. Oh, God. You got a lot of fun with this. Holy shit. There's a 10-band EQ. Where's that? Was that in filter? I don't think so. This is cool. Man, there's a lot of cool stuff. I had to put 10 PSI on all 4 of my tires. Jesus. That is very true. It's embarrassing how often I go back to using a Teensy for random crap. You and me both. You and me both, my friend. They're the perfect, like, they're so powerful just to throw onto to throw on a breadboard and just do up your, like, digital circuit. That's what the steering wheel project was. There's a Teensy in there that actually takes the signals from actual car accessories, including a like an actual car wheel that speaks on something called the LIN bus. We reverse engineered it. And we figured out what codes the steering wheel listens to, apart from actually the backlighting. I would like to get the backlighting working on that someday. But yeah, that's all coordinated by a Teensy that's using basically bit banging in order to create LIN bus signals, which is pretty cool. We reverse engineered actual car hardware. And then in order to take other car hardware signals in, I had to make my own LIN bus device. We used AT-Tiny 85s for that to communicate back on LIN bus. All right, so that's stupid powerful. All right, someday we're going to visit this and we're going to have fun playing with it. We'll have to come back to that. You guys remind me that it actually exists, because goddamn is that cool. We do a lot of really interesting stuff with all this. Up to 4 stages may be cascaded. So more than 4 stages and the Teensy is not happy with you. Where are the 10 bands, though? Which one is that? Because I just don't see it anywhere in here. I'm sure it exists. Because there's the amp and then there's the mixer. Combine 4 signals together with adjustable gain. Anyway. Teensy audio. Very cool. I should have seen this earlier. I could have put something together using that. So anyway, okay, so next stream we're either gonna do burn the subs, and that'll be more Fusion 360, or we're gonna check out prepping for the breadboard, right? You're trying to be hype about the hype train, and you choo-choo, and then you put that emote there, and it looks like a sad dog. It doesn't really look like a hype dog. All right, cool. Well, anyway, yeah, catching you guys all up in work. We got a little bit of research done. Unfortunately, this is a little bit booky. We had to do a little bit more reading than we had anticipated today. But I'll be back on Thursday, and we'll get to actually doing stuff, either through Fusion, which will look pretty, or we'll do stuff with building circuits. Let me just take a look at who's out there right now. My sound is on. Turn the sound off. We got the big names. We got the Rabaz. What is he doing? Mountain Home? Oh, Mountain Home's pretty cool, actually. That was a neat game. I think if that's the one that I think it was. I'm gonna click it and see what he's doing. Never mind, that's not at all what I think it is. It's just a top-down game. Davies is going. you can probably guess what he's doing. He's got 100 people there, man. Okay, anyway, yeah, I'm just gonna shut it down today. Small woodworking stream. Maybe another time. Too bad no one streams Fusion. Well, we'll do a little bit more. Fusion likes to kind of like dox you. It's a tough program to stream because like my email has been like, it's like, oh hey you with your email ready available over there. All right, anyway, we're gonna come back tomorrow or Thursday, and we're gonna do more audio stuff or more burn the subs. Either way, it's gonna be interesting. We're gonna be a little bit more hands-on. I want to thank you guys for following, and also for the people who subbed to the stream. I appreciate that. We are between boards right now. We got a lot of work to do. I had an existential crisis about it. We're gonna work on it at our own pace, and we're gonna get it done, even though chat's gonna be snippy about it the whole way. Can't please everybody, so that's just where we are. I'll see you guys on Thursday, and until then, yeah, go out to the other parts of Twitch and have fun. All right? Have a good one, everybody. What button do I press again? Oh yeah, this one.